The vanishing of Paititi. Imagine standing at the edge of the Amazon rainforest, where the last rays of sunlight filter through an emerald canopy that has concealed secrets for over 500 years. The air is thick with moisture and the whispered promises of ancient mysteries. Somewhere in this vast wilderness lies Paititi, the legendary golden city where the final Inca rulers supposedly fled with their empire's greatest treasures. You can almost feel the weight of centuries pressing against your shoulders as you peer into the green depths, knowing that despite satellite technology, ground-penetrating radar, and countless expeditions, this refuge remains as elusive as a whisper in the wind. Spanish chroniclers wrote of its existence with trembling hands. Indigenous legends speak of golden temples that caught the morning light like fallen stars. Yet modern science has found no trace of this lost sanctuary. Was Paititi deliberately hidden by sophisticated camouflage techniques that surpassed anything we understand about Inca engineering? Or does it exist in a dimension beyond our current grasp of what ancient civilizations could achieve? Historical context. To understand the mystery of Paititi, we must first journey back to the twilight of the Inca Empire. In 1532, when Spanish conquistadors, under Francisco Pizarro, arrived in Peru, they encountered the Tahuantinsuyu, an empire that stretched from modern-day Colombia to Chile, encompassing over 12 million people. The Incas had built their civilization on foundations of gold, both literal and metaphorical. Gold was not merely wealth to them, it was the sweat of Inti, their sun god, sacred and irreplaceable. When Atahualpa, the last great Inca emperor, was captured by the Spanish, he offered a ransom that would echo through history, a room filled once with gold and twice with silver. The Spanish accepted, melted down priceless artifacts into bars, and then executed Atahualpa anyway. This betrayal shattered more than an empire. It shattered trust between two worlds. But not all Inca gold fell into Spanish hands. As news of Atahualpa's death spread through the empire, many regional leaders began a desperate exodus. They gathered the most sacred artifacts, the accumulated wealth of generations, and the knowledge keepers of their civilization. According to both Spanish accounts and indigenous oral traditions, these refugees fled not to the familiar highlands, but eastward into the Amazon basin, seeking sanctuary in a place the Spanish would never dare to follow. This hidden refuge became known as Paititi, derived from the Quechua word for the same as the father, perhaps indicating it was meant to recreate the glory of Cusco itself. Spanish chroniclers like Pedro Sarmiento de Gamboa wrote that Manco Inca, Atahualpa's successor, established this secret city beyond the great waters, where the houses were roofed with gold. The city was said to be protected not just by distance and terrain, but by sophisticated defenses that could conceal it from unwanted eyes. Discovery. The modern search for Paititi began not with archaeologists or historians, but with adventurers drawn by tales of gold. In 1901, British explorer Percy Fawcett ventured into the Brazilian Amazon, convinced he would find not just Paititi, but an entire lost civilization he called Z. Fawcett disappeared in 1925, becoming part of the mystery he sought to solve. The search intensified in the late 20th century as technology offered new tools. In 1964, American explorer Jean Savoy claimed to have discovered Paititi at a site called Gran Pajatan in Peru's cloud forests. The ruins he found were indeed impressive circular stone structures, terraces, and what appeared to be ceremonial platforms. But carbon dating revealed these structures predated the Inca Empire by centuries, belonging instead to the Chachapoya culture. Satellite imagery revolutionized the search in the 1980s and 90s. Researchers began analyzing thousands of square miles of Amazon rainforest, looking for geometric patterns that might indicate human settlement. They found intriguing formations, straight lines cutting through jungle, circular clearings, and raised platforms that could be ancient construction. Yet every promising lead, investigated on the ground, turned out to be natural formations or settlements from other cultures. In 2006, Italian archaeologist Mario Poglia claimed he had found Spanish colonial documents describing the exact location of Paititi. The documents, allegedly discovered in the archives of the Jesuit order in Rome, described a city of stone buildings connected by bridges, surrounded by walls and filled with gold artifacts. Poglia organized expeditions to southeastern Peru based on these descriptions, but despite finding Inca ruins in the area, he did not locate the grand city described in the documents. Theories. The persistence of the Paititi legend, despite centuries of fruitless searching, has generated numerous theories, each attempting to explain why this city remains hidden while other Inca sites have been discovered and studied. The geographic concealment theory suggests that Paititi exists in one of the Amazon's most inaccessible regions, perhaps in the headwaters of remote tributaries where dense canopy cover makes aerial detection impossible. Proponents point out that new species are still being discovered in these areas, indicating how much remains unexplored. They argue that Inca engineers, masters of adapting architecture to difficult terrain, could have built a city that appears natural from above, while remaining functional below the canopy. The seasonal flood theory proposes that Paititi was built in an area subject to dramatic seasonal changes. During flood seasons, the city might be partially submerged, while during dry periods, it could be concealed by vegetation growth. This would explain why satellite imagery has failed to reveal consistent geometric patterns. The city's appearance changes dramatically with the seasons. The advanced camouflage theory suggests that the Incas developed sophisticated techniques for hiding their final refuge. This theory points to examples of Inca architecture that seems to blend seamlessly with natural rock formations. At Sacsayhuaman and other sites, Inca stonework is so precisely fitted to natural outcroppings that it becomes difficult to distinguish human construction from natural formation. Perhaps the builders of Paititi perfected these techniques to create a city that appears entirely natural from any aerial perspective. The multiple sites theory proposes that Paititi was never a single city but rather a network of hidden settlements throughout the Amazon basin. As Spanish pressure intensified, Inca refugees might have established several smaller communities, each preserving different aspects of their civilization. Over time, legends of these various sites merged into stories of one great golden city. The spiritual dimension theory, favored by some indigenous communities, suggests that Paititi exists in a spiritual realm accessible only to those who approach with proper rituals and intentions. This theory draws on Inca concepts of Aini reciprocal relationship with the natural world and suggests that the city reveals itself only to those who understand and respect these ancient principles. Scientific investigations. Modern technology has brought increasingly sophisticated tools to the search for Paititi, yet each advance seems to deepen rather than resolve the mystery. Satellite imagery analysis has covered millions of acres of Amazon rainforest using multispectral sensors that can detect subtle variations in vegetation patterns. These variations sometimes indicate buried structures or altered soil composition from ancient human activity. Several promising sites have been identified this way, including geometric patterns near the headwaters of the Madre de Dios River and unusual straight-line formations in the Manu National Park region. However, ground investigations have consistently revealed natural formations or evidence of pre-Inca cultures rather than the Golden City of legend. Ground-penetrating radar surveys have been conducted at dozens of suspected sites throughout Peru and Bolivia. This technology can detect buried structures, modified soil layers, and metallic objects underground. In 2012, a team from the University of California conducted extensive radar surveys in the Cosñipata Valley, an area long suspected to harbor Paititi. They discovered several buried structures and what appeared to be a network of ancient roads, but excavations revealed these to be from much earlier civilizations. LiDAR technology, which uses laser pulses to create detailed topographic maps even through dense forest canopy, has revolutionized archaeological discovery in other regions. The same technology that revealed vast Maya cities hidden beneath jungle growth in Guatemala has been applied to potential Paititi sites. In 2018, a consortium of international researchers conducted LiDAR mapping of over 2,000 square miles of Peruvian Amazon. The results showed numerous previously unknown archaeological sites, but none matching the descriptions of the Great Refuge City. Environmental DNA analysis offers another approach to the mystery. This technique involves collecting soil and water samples to detect genetic traces of plants and animals that might indicate human habitation. Research teams have used this method to identify ancient agricultural sites and settlements throughout the Amazon. Some samples from remote tributaries have revealed traces of crops that don't naturally occur in those regions, suggesting past human transportation and cultivation, but these findings have not yet led to the discovery of significant ruins. Carbon isotope analysis of river sediments provides clues about ancient human activity by detecting changes in erosion patterns that might indicate large-scale construction or agriculture. Studies of sediment cores from rivers in southeastern Peru show periods of increased erosion that correlate with the final centuries of Inca presence in the region, but these patterns are consistent with many possible explanations beyond a hidden city. Modern challenges. The search for Paititi faces unprecedented challenges in the 21st century, as the Amazon rainforest itself becomes increasingly threatened. Deforestation for agriculture, mining, and development has accelerated dramatically, destroying potential archaeological sites before they can be discovered or studied. Areas that might once have concealed ancient ruins are being cleared at rates that make systematic archaeological survey impossible. Climate change has altered weather patterns throughout the Amazon basin, affecting both the preservation of archaeological sites and the conditions under which researchers can work. Increased flooding in some areas and severe drought in others are damaging potential sites while making access more difficult and dangerous for research teams. The rights and concerns of indigenous communities present both ethical considerations and practical challenges for Paititi research. Many indigenous groups consider certain areas of the Amazon to be sacred and off-limits to outsiders, regardless of their research intentions. Respecting these cultural boundaries is essential, but it also means that large areas that might contain archaeological evidence remain unexplored. Illegal activities throughout the Amazon, including drug trafficking, illegal mining, and armed groups, have made many regions too dangerous for archaeological expeditions. Some of the most remote areas where Paititi might logically be hidden are now controlled by criminal organizations that make scientific research impossible. The commercialization of the Paititi legend has also complicated serious research efforts. Treasure hunters, adventure tourism companies, and documentary filmmakers have all contributed to the proliferation of unsubstantiated claims and false discoveries, making it difficult for the public to distinguish between legitimate archaeological research and sensationalized treasure hunting. Closing reflections. As we stand again at that forest edge where our journey began, the mystery of Paititi seems as deep as the Amazon itself. Perhaps the question is not whether this golden refuge existed, but what it represents in our collective understanding of human resilience and adaptation. The Inca Empire, for all its achievements, was not immune to the forces of change and conquest that have shaped human history. In their final desperate flight into the Amazon, the survivors carried more than gold. They carried the hopes, knowledge, and spiritual essence of a civilization. Whether Paititi exists as a physical city waiting to be discovered, or as a symbol of cultural continuity preserved in the memories and traditions of indigenous communities, its power remains undiminished. Modern technology continues to evolve, offering new possibilities for discovery. Artificial intelligence analysis of satellite imagery improved ground-penetrating radar, and advances in environmental DNA sampling may yet reveal what centuries of searching have not. But perhaps the greatest discoveries will come not from our instruments, but from listening more carefully to the indigenous voices who have always known these forests and their secrets. The Amazon keeps its mysteries close, revealing them only when the time is right, and to those who approach with proper respect. Until that moment arrives, Paititi remains what it has always been, a golden dream, shimmering just beyond the edge of the known world, calling to us from the green heart of an ancient and enduring mystery. What do you think happened to the Inca's final refuge? Share your theories in the comments below, and subscribe for more ancient mysteries that continue to challenge our understanding of human history. The impossible stones of Sacsayhuaman. Picture yourself running your hand along stones so perfectly fitted that not even a knife blade can slip between them. Stones weighing up to 200 tons, transported from quarries miles away and lifted to impossible heights. No mortar binds these megaliths, yet they have withstood centuries of earthquakes that reduced Spanish buildings to rubble. How did the Incas move these blocks without wheels, without pulleys, without modern engineering? The stones remain silent witnesses to an impossible achievement. Historical context. To understand the mystery of Sacsayhuaman, we must journey back to the height of the Inca Empire in the 15th century. The fortress overlooks Cusco, the sacred capital that the Incas called the navel of the world. From this elevated position, Sacsayhuaman served as both a military stronghold and a sacred ceremonial center, its very name meaning satisfied falcon in the Quechua language. The construction began during the reign of Pachacuti Inca Yupanqui around 1450, but the massive undertaking continued for nearly a century under his successors Tupac Inca Yupanqui and Huayna Capac. Spanish chronicler Garcilaso de la Vega, writing in the late 16th century, described the fortress as one of the architectural marvels of the ancient world. According to his accounts, over 20,000 workers labored for more than 60 years to complete the structure. The fortress was designed as 3 massive terraced walls that zigzag across the hillside for over 1,000 feet. These walls form the teeth of the falcon, with the body of the bird represented by the ceremonial plaza and buildings that once crowned the summit. The largest stones, some weighing more than a modern locomotive, were positioned in the lower walls where their mass would provide maximum stability. But Sacsayhuaman represented more than military engineering. To the Incas, it embodied their cosmological understanding of the universe. The fortress was aligned with astronomical events, its walls pointing towards solstices and equinoxes. The entire complex functioned as a massive calendar carved in stone, marking the passage of time and the cycles of agricultural seasons that governed Inca life. When the Spanish conquistadors arrived in Cusco in 1533, they were astounded by what they found. Pedro Sancho, Francisco Pizarro's secretary, wrote that the stones were so large and perfectly fitted that they seemed the work of demons rather than men. The Spanish recognized the military threat posed by such an impregnable fortress and immediately began dismantling parts of it to build their own colonial structures in Cusco below. Discovery. While Sacsayhuaman was never truly lost to history, its secrets began to reveal themselves to modern investigators only in the 19th and 20th centuries. The first systematic studies were conducted by German archaeologist Max Uhle in the early 1900s, who began documenting the precise measurements and construction techniques employed by the Inca builders. The true scale of the engineering achievement became apparent in the 1940s when American archaeologist John Rowe conducted detailed surveys of the site. Rowe discovered that the largest stones had been quarried from sites up to 20 miles away, requiring transportation across rivers, valleys, and steep mountain terrain. Even more remarkably, many stones showed evidence of being partially carved at the quarry site, then finished with incredible precision at their final destination. In 1968, a devastating earthquake struck the Cusco region, measuring 7.5 on the Richter scale. Modern buildings throughout the city suffered severe damage or collapsed entirely, yet the ancient walls of Sacsayhuaman remained completely intact. Not a single stone shifted from its position, despite the fact that no mortar held them together. This event marked a turning point in how archaeologists and engineers viewed Inca construction techniques. Detailed photographic documentation in the 1970s revealed additional mysteries. Close examination showed that many stones had multiple contact surfaces, some fitting against as many as 12 neighboring blocks simultaneously. The complexity of these three-dimensional intersections suggested a level of geometric understanding and planning that seemed impossible without modern computational tools. Ground-penetrating radar surveys conducted in the 1990s discovered that the visible walls represent only a fraction of the original construction. Beneath the soil lie additional courses of stones, suggesting that the fortress was even more massive than previously thought. These buried sections also showed the same impossible precision in stone fitting, indicating that the entire structure was built to standards that defy conventional understanding of ancient capabilities. Theories. The seemingly impossible precision and scale of Sacsayhuaman have generated numerous theories attempting to explain how such construction was possible with the tools and knowledge supposedly available to the Incas. The advanced tool theory proposes that the Incas possessed sophisticated cutting and shaping tools that have been lost to history. Proponents point to evidence of precise tool marks on some stones that suggest cutting instruments far sharper and more accurate than bronze implements. Some researchers have speculated that the Incas developed hardened bronze alloys, or even primitive steel tools that could carve the local limestone and andesite with surgical precision. However, no such tools have been discovered, and metallurgical analysis of known Inca implements shows no evidence of such advanced technology. The acoustic levitation theory suggests that the Incas understood sound manipulation techniques that could reduce the effective weight of massive stones. This theory draws on legends recorded by Spanish chroniclers describing how Inca priests could make stones dance or fly through the air using special chants and musical instruments. Modern research into acoustic levitation has demonstrated that sound waves can indeed suspend small objects, but scaling this effect to move 200-ton blocks would require sound frequencies and amplitudes far beyond what ancient instruments could produce. The lost technology theory proposes that the Incas inherited advanced construction techniques from an even earlier civilization. This theory suggests that the precise stone cutting and fitting methods were developed over thousands of years by predecessor cultures and perfected by the Incas. Archaeological evidence does show that sophisticated stoneworking techniques existed in the Andes for millennia before the Inca Empire, but none of the earlier examples approach the scale and precision seen at Sacsayhuaman. The geopolymer theory offers a radically different explanation, suggesting that the stones of Sacsayhuaman are not carved blocks at all, but rather artificial concrete-like materials molded in place. French chemist Joseph Davidovits has proposed that ancient builders could have created stone-like substances using naturally occurring minerals and organic acids. This would explain the perfect fitting between blocks they were cast directly against each other while still malleable. However, geological analysis of Sacsayhuaman stones consistently identifies them as natural andesite and limestone quarried from known sources. The extended timeline theory suggests that the construction took far longer than historical records indicate, allowing for the gradual refinement of techniques over centuries or even millennia. This theory proposes that the fortress was built and rebuilt multiple times, with each generation improving upon their predecessor's work. While this could explain the extraordinary precision, carbon dating of organic materials found within the walls consistently places construction within the time frame described in Spanish chronicles. Scientific investigations. Modern scientific analysis has brought increasingly sophisticated tools to bear on the mystery of Sacsayhuaman. Yet each new discovery seems to deepen rather than resolve the puzzle of its construction. Laser scanning technology has created detailed three-dimensional maps of the fortress walls, revealing the full complexity of the stone fitting problem. These scans show that individual blocks have contact surfaces that follow curved and angled planes, creating interlocking patterns that would require extraordinary precision to achieve. Computer modeling suggests that positioning such stones would require knowledge of advanced geometry and mathematical principles that exceeded what we know of Inca capabilities. Petrographic analysis has identified the exact quarry sources for different stones within the walls. Some blocks came from Wakoto Quarry, over 15 miles away, while others originated from sites even more distant. The logistics of transporting stones weighing hundreds of tons across such distances without wheels or large draft animals represents an engineering challenge that modern contractors would find daunting, even with contemporary equipment. Ground-penetrating radar and magnetic resonance imaging have revealed the internal structure of the walls, showing that the precision extends throughout the entire thickness of each block. The stones are not merely fitted on their visible surfaces, they maintain their perfect fit completely through their depth. This discovery eliminates theories that suggested the Incas used external molds or forms to shape only the visible portions of the blocks. Microscopic analysis of stone surfaces has revealed tool marks that provide clues about construction techniques. These marks suggest the use of cutting implements that could create smooth, precise surfaces on extremely hard stone. However, the patterns are unlike those created by any known ancient tools, leading some researchers to speculate about unknown cutting methods or instruments. Seismological studies following recent earthquakes have shown that the walls of Sacsayhuaman actually become more stable under seismic stress. The lack of mortar, which might seem like a weakness, actually allows the stones to move slightly during earth tremors, dissipating energy rather than accumulating stress that could cause collapse. This anti-seismic design principle was not understood by European engineers until the 20th century. Modern challenges. The preservation of Sacsayhuaman faces numerous challenges in the 21st century, as tourism, urban development, and environmental factors threaten this irreplaceable archaeological treasure. Mass tourism has brought millions of visitors to the site, creating both economic benefits and conservation problems. The constant foot traffic over centuries-old stones has caused gradual erosion, while the oil from countless hands touching the walls has begun to discolor and degrade some surfaces. Balancing public access with preservation requires constant monitoring and management that strains available resources. Urban expansion from Cusco has encroached upon the archaeological site, with illegal construction and informal settlements appearing on land that may contain buried portions of the original complex. Development pressure has led to conflicts between local communities seeking housing and archaeologists attempting to preserve potential discoveries. Climate change has altered weather patterns in the Cusco region, bringing more intense rainfall during some seasons and prolonged drought during others. These extreme conditions accelerate the weathering of exposed stones and can cause ground shifting that affects the stability of walls that have stood unchanged for centuries. Air pollution from increased vehicle traffic and industrial activity in the Cusco Valley has begun to affect the stones themselves. Chemical analysis shows that pollutants are gradually changing the surface chemistry of the blocks, potentially leading to long-term deterioration that could threaten the structural integrity of the walls. Vandalism and theft remain ongoing concerns, with some visitors attempting to chip off pieces of stone as souvenirs. While most such attempts cause only minor damage, the cumulative effect over time could be significant. Security measures must balance protection with accessibility for legitimate research and educational purposes. Closing reflections. As we stand once more before these impossible stones, feeling their massive presence and perfect precision, the mystery of Sacsayhuaman seems as profound as ever. Each scientific advance reveals new layers of complexity rather than simple answers. The fortress challenges not just our understanding of ancient capabilities, but our assumptions about the linear progress of human knowledge and technology. Perhaps the greatest mystery lies not in how the stones were cut and fitted, but in why such extraordinary effort was invested in their placement. The Incas could have built effective fortifications using simpler construction methods, yet they chose to create something that transcends mere functionality. Sacsayhuaman stands as a testament to human aspiration that reaches beyond the practical toward the sublime. The stones continue to teach us, their lessons written in a language of precision and permanence that speaks across centuries. They remind us that our ancestors possessed capabilities we are still struggling to understand, and that the boundaries between possible and impossible may not be as fixed as we assume. Modern engineering continues to study Sacsayhuaman, seeking to unlock its secrets for contemporary applications. Anti-seismic construction techniques, precision fitting methods, and sustainable building practices all have lessons to learn from these ancient walls. Perhaps the Incas built not just a fortress, but a library of knowledge encoded in stone. As the sun sets over these eternal walls, casting the same shadows that have fallen here for centuries, we are left with questions that may be more valuable than answers. Sacsayhuaman stands as proof that human achievement can transcend the limitations of any single era, creating monuments that speak to possibilities we have yet to imagine. What do you think explains the impossible precision of these ancient walls? Share your theories in the comments below, and subscribe for more mysteries that challenge our understanding of what our ancestors could achieve. The silent astronomers of Lactapata envision climbing through cloud forest to discover stone platforms that seem to capture starlight itself. At Lactapata and similar sites throughout the Inca realm, mysterious astronomical observatories point towards celestial events with mathematical precision rivaling modern instruments. Most puzzling, many observatories were deliberately abandoned before fulfilling their apparent purpose. Windows carved to frame specific constellations were left unused, calendrical stones positioned but never activated. Did the Incas foresee some cosmic event that never came to pass? Historical context. The Inca Empire, known as Tahuantinsuyu, was built upon astronomical knowledge that permeated every aspect of their civilization. From 1438 to 1532, this culture constructed an intricate network of celestial observation posts across their vast territory. To the Incas, the sky was a living map that guided agricultural cycles, religious ceremonies, and imperial life. At the heart of this system stood sequoia lines, invisible pathways radiating from Cusco like spokes on a cosmic wheel. These sacred lines connected huacas, or holy sites, many serving dual purposes as religious shrines and astronomical observation points. The Incas believed these alignments channeled celestial power into the earthly realm, creating harmony between heaven and earth. Lactapata, meaning high town in Quechua, represents one of the most sophisticated examples of Inca astronomical architecture. Built on a ridge overlooking the Urubamba Valley, 50 miles northwest of Cusco, this site commanded sweeping views of surrounding mountains and the star-filled Andean sky. Construction began during Pachacuti Inca Yupanqui's reign in the mid-15th century. The site was positioned to observe key astronomical events governing Inca society. The June solstice, marking the new year, was tracked through carved stone windows. The Pleiades constellation's rising, signaling agricultural season's start, was monitored through alignment stones pointing toward mountain peaks. Planetary movements were recorded through intricate stone calendars functioning as timepieces and prophecy tools. Discovery. The rediscovery of Lactapata as an astronomical site began in the early 20th century, though the ruins themselves had never been completely lost to local indigenous communities. American explorer Hiram Bingham first documented the site in 1915 during his expeditions to map Inca ruins in the Sacred Valley. However, Bingham focused primarily on the more dramatic discoveries at Machu Picchu, leaving Lactapata's astronomical significance unexplored for decades. The true astronomical nature of Lactapata was not recognized until 1980, when archaeoastronomer Dr. Johann Reinhard began systematic studies of the site's alignments. Reinhard discovered that the principal structures were oriented with mathematical precision toward key astronomical events. Stone windows framed the December solstice sunrise with an accuracy that differed by less than half a degree from perfect alignment. Even more intriguing was Reinhard's discovery of what he termed future alignments, astronomical orientations that pointed toward celestial events that had not yet occurred when the structures were built. Computer modeling revealed that some windows were positioned to frame star alignments that would not manifest for decades or even centuries after construction. This suggested a level of astronomical prediction that seemed impossible with the observational tools supposedly available to the Incas. In 2001, a joint expedition by the University of California and Peru's National Institute of Culture used ground-penetrating radar to map the full extent of Lactapata's structures. The survey revealed that the visible ruins represented only a fraction of the original complex. Buried beneath centuries of vegetation lay additional observation platforms, underground chambers aligned with celestial events, and a network of channels that may have been used for astronomical observations involving water reflection. The most startling discovery came in 2007, when detailed mapping revealed that several key structures at Lactapata had been deliberately dismantled before their astronomical functions could be completed. Stone blocks had been carefully removed and stacked nearby, as if the builders had suddenly halted construction and prepared to abandon the site. Tool marks on partially carved alignment stones showed that work had ceased abruptly, leaving astronomical windows half-finished and calendrical markers incomplete. Theories. The mystery of Lactapata's abandoned astronomical functions has generated numerous theories, each attempting to explain why the Incas would cease work on such sophisticated observational tools just before they reached completion. The Spanish conquest interruption theory suggests that construction was halted due to the arrival of Spanish conquistadors and the subsequent collapse of the Inca Empire. Proponents argue that news of Atahualpa's capture in Cajamarca in 1532 would have disrupted all imperial construction projects, forcing workers to abandon their posts and flee to safety. This theory explains the abrupt cessation of work, but fails to account for why some sites appear to have been abandoned years before Spanish arrival, or why certain astronomical alignments seem designed for future events that would occur long after the empire's fall. The failed prophecy theory proposes that the Incas were preparing for a specific cosmic event that they incorrectly calculated or misinterpreted. This theory suggests that Inca astronomers, using their sophisticated observational methods, predicted a celestial occurrence that would have profound spiritual or political significance. When the predicted event failed to materialize as expected, confidence in the astronomical system collapsed, leading to the abandonment of observational sites. Archaeological evidence supporting this theory includes partially completed structures that seem designed for one-time celestial events rather than recurring observations. The hidden knowledge theory suggests that the observatories at Lactapata and similar sites were designed to detect or communicate with cosmic phenomena beyond normal astronomical observation. This theory proposes that Inca astronomers possessed knowledge of celestial mechanics that enabled them to predict rare cosmic events, such as supernovae, comet appearances, or unusual planetary alignments. When this knowledge revealed that a significant event was not imminent, or when it became clear that the intended observations were not yielding expected results. The sites were abandoned to prevent misuse by unauthorized individuals. The temporal displacement theory offers a more speculative explanation, suggesting that the Incas understood concepts of time and celestial mechanics that transcended linear chronology. This theory proposes that the astronomical alignments were designed not for immediate observation, but for activation at some future point when cosmic conditions would be optimal. The abandonment was not a failure, but a deliberate preservation strategy, ensuring that the sites would remain intact until the proper astronomical moment arrived. The resource reallocation theory provides a more practical explanation, suggesting that the astronomical projects were abandoned due to changing imperial priorities rather than cosmic considerations. As the Inca Empire faced increasing external pressures and internal challenges in the early 16th century, resources that had been dedicated to astronomical projects may have been redirected toward more immediate military and administrative needs. This theory is supported by evidence that skilled stoneworkers from astronomical sites were reassigned to defensive construction projects during the empire's final decades. Scientific investigations. Modern scientific analysis has brought increasingly sophisticated tools to bear on the mystery of Lactapata's abandoned astronomical functions, revealing layers of complexity that deepen rather than resolve the puzzle. Astronomical modeling using advanced computer simulations has reconstructed the night sky as it appeared from Lactapata during the 15th and 16th centuries. These models confirm that many of the site's alignments were indeed oriented towards significant astronomical events, with precision that rivals modern observatory instruments. However, the modeling also reveals that some alignments point towards celestial configurations that would not occur for centuries after construction, suggesting either remarkable predictive abilities or purposes beyond immediate observation. Archaeoastronomical surveys using GPS technology and laser measurement tools have mapped the precise orientations of stone structures throughout the site. These measurements reveal alignment accuracies of less than 1 degree of arc, demonstrating a level of precision that would be challenging to achieve even with modern surveying equipment. The surveys also confirm that many structures were indeed abandoned before completion, with foundation stones positioned for future construction that never occurred. Ground-penetrating radar and magnetic anomaly detection have revealed the full extent of underground structures at Lactapata. These subsurface surveys show that the astronomical complex was far more extensive than surface ruins, with underground chambers and passages that may have served specialized observational functions. Some underground spaces are aligned with astronomical events that occur below the horizon, suggesting that the Incas understood and utilized concepts of spherical astronomy that were not formally developed in Europe until the Renaissance. Spectrographic analysis of stone surfaces has revealed tool marks that provide clues about construction techniques and the timing of abandonment. These microscopic examinations show that work on astronomical alignment features ceased uniformly across the site, suggesting coordinated rather than gradual abandonment. The analysis also reveals evidence of deliberate preservation efforts, with stone surfaces treated to prevent weathering, as if the builders expected to return and complete their work. Paleoclimatic studies using tree ring data, ice cores, and sediment analysis have reconstructed weather conditions during the period of Lactapata's construction and abandonment. These studies reveal no significant climate events that would have forced abandonment, but they do show subtle changes in atmospheric conditions that might have affected astronomical observation quality. Some researchers speculate that these changes could have rendered certain delicate astronomical alignments less effective, contributing to the decision to abandon the site. Modern challenges. The preservation and study of Lactapata face numerous challenges that threaten both the physical site and our ability to understand its astronomical significance. Climate change has altered weather patterns throughout the Andes, bringing more intense rainfall and temperature fluctuations that accelerate the weathering of exposed stone structures. The cloud forest environment that once protected the site from extreme weather now experiences more frequent storms and temperature swings that stress ancient masonry joints and carved stone surfaces. These changes are gradually eroding the precise alignments that make the site astronomically significant. Tourism pressure has increased dramatically as awareness of Lactapata's significance has grown. While this brings needed attention and resources for conservation, it also creates physical stress on fragile structures. Foot traffic over centuries-old stone pavements causes gradual wear, while the installation of visitor facilities requires careful planning to avoid disrupting astronomical alignments. Light pollution from the growing city of Cusco and increased air traffic over the Sacred Valley now interferes with astronomical observations from the site. The dark skies that once made Lactapata an ideal observation post are increasingly compromised by artificial illumination, making it difficult for researchers to experience the site as the Incas would have seen it. This pollution also affects efforts to use modern astronomical observations to verify ancient alignments. Illegal artifact hunting and vandalism pose ongoing threats to the site's archaeological integrity. Some visitors attempt to move or mark alignment stones, not realizing that even small disturbances can destroy astronomical accuracy that has been preserved for centuries. Security measures must balance protection with access for legitimate research and education. Funding limitations restrict the scope and continuity of research at Lactapata. The specialized equipment and expertise required for archaeoastronomical studies are expensive, while the remote location makes extended research campaigns logistically challenging. These constraints limit our ability to fully understand the site's astronomical functions before environmental degradation causes irreversible damage. Closing reflections. As we stand among the silent stones of Lactapata, watching the same stars that once guided Inca astronomers across these ancient skies, the mystery deepens rather than resolves. These abandoned observatories speak to us across centuries, their unfinished alignments raising questions that touch the very heart of human ambition and cosmic understanding. Perhaps the greatest mystery is not why the Incas abandoned these remarkable instruments, but what they hoped to achieve through such precise celestial observation. The astronomical alignments represent more than scientific curiosity. They embody a worldview that saw profound connections between earthly events and cosmic rhythms, between human destiny and stellar movements. The deliberate abandonment of Lactapata suggests that the Incas made a conscious choice to halt their astronomical pursuits. But we can only speculate about their reasoning. Did they discover something in the stars that made further observation unnecessary or unwise? Were they preparing for cosmic events that our modern understanding of astronomy cannot yet comprehend? Or did they simply recognize that some mysteries are meant to remain unsolved? Modern astronomy continues to discover new aspects of celestial mechanics and cosmic phenomena that were unknown just decades ago. Dark matter, gravitational waves, and quantum entanglement suggest that the universe contains layers of complexity that may be far beyond our current comprehension. Perhaps the Inca astronomers intuited aspects of cosmic reality that we are only beginning to approach through our most advanced scientific instruments. The stone windows of Lactapata continue to frame the same celestial events they were designed to observe, waiting patiently for purposes we may never fully understand. They remind us that human knowledge is always provisional, always incomplete, and that the greatest discoveries may lie not in what we can measure and explain, but in what we are humble enough to acknowledge as mystery. As darkness falls over the Sacred Valley and the ancient stars emerge in their eternal patterns, we are left with questions that may be more valuable than answers. What cosmic secrets did the Inca astronomers hope to unlock? What did they see in these stars that made them pause at the threshold of discovery? What do you think caused the Incas to abandon their remarkable astronomical observatories? Share your theories in the comments below. and subscribe for more ancient mysteries that challenge our understanding of what our ancestors knew about the cosmos above. The underground web of Cusco. Imagine descending into tunnels beneath Cusco that stretch further than anyone has dared to map, forming a subterranean city as complex as the one above. Spanish conquistadors wrote of vast underground chambers filled with gold artifacts, connected by passages honeycombing the earth beneath the Inca capital. Modern ground-penetrating radar confirms these accounts, revealing voids and corridors extending in all directions. Yet systematic exploration remains incomplete. What purpose did this shadow city serve? Historical context. Cusco, the sacred capital of the Inca Empire, was far more than a surface city of stone temples and royal palaces. Known as the navel of the world, Cusco represented the spiritual and political heart of Tahuantinsuyu. But beneath the magnificent architecture lay another realm entirely, a vast network of underground passages, chambers, and galleries that mirrored the complexity of the city above. Construction began during Manco Capac's reign around 1200. Each successive emperor expanded the underground network, creating a parallel city, serving multiple sacred and practical purposes. The tunnels were integral to Inca understanding of the cosmos, representing the underworld realm of Ukupacha in their three-tiered vision of reality. Underground passages connected Cusco's most important temples and royal compounds, allowing priests and nobles to move unseen between sacred sites during religious ceremonies. The Coricancha, Cusco's principal temple dedicated to the sun god Inti, was said to be the hub of this subterranean web, with tunnels radiating outward like sun rays. These passages were lined with gold sheets and contained repositories of sacred artifacts. Spanish chronicler Pedro Cieza de León wrote in 1553 that the tunnels contained more riches than have ever been seen in the world, describing chambers filled with golden statues, precious textiles, and mummified remains of Inca rulers. The underground spaces also served as repositories for administrative records kept on quipu intricate knotted cord systems, encoding tribute payments to astronomical observations. Discovery. The modern rediscovery of Cusco's underground network began not through archaeological investigation, but through accident and urban development. In 1968, a devastating earthquake measuring 7.5 on the Richter scale struck the Cusco region. While the tremors damaged many colonial buildings, they also opened previously sealed entrances to the underground system, revealing glimpses of what lay hidden beneath the city. Local residents had always known about some tunnel entrances, particularly those that connected to colonial-era cellars and basements. But the earthquake revealed the true scope of the underground network, exposing passages that extended far beyond what anyone had imagined. Initial explorations by amateur spelunkers in the early 1970s documented tunnels that stretched for miles in every direction, with chambers large enough to hold hundreds of people. The first systematic investigation began in 1982, when Dr. Anselm Pi Rambla, a Peruvian archaeologist, organized official expeditions into the accessible portions of the tunnel system. Pi Rambla's team mapped over 3 miles of passages before encountering areas that were either flooded, blocked by debris, or considered too dangerous to explore. They discovered carved niches that once held golden artifacts, stone altars still bearing traces of ceremonial offerings, and chambers with walls covered in intricate geometric patterns. In 2001, ground-penetrating radar surveys conducted by the University of California revealed the staggering extent of the underground network. The radar detected voids and passages honeycombing the earth beneath virtually the entire historical center of Cusco. The system appeared to extend outward from the city center for several miles in each direction, suggesting a subterranean complex that might rival the surface city in size and complexity. More recent investigations, using advanced sonar and thermal imaging, have confirmed that many passages remain unexplored. Some are blocked by collapsed sections caused by earthquakes over the centuries. Others are permanently flooded by changes in the local water table. And still others are inaccessible due to their locations beneath modern buildings and infrastructure. Perhaps most intriguingly, local indigenous communities have maintained that certain entrance points to the tunnel system remain actively protected. These guardians, descendants of the original Inca inhabitants, claim that some chambers still contain sacred artifacts and mummified remains that must be protected from disturbance. Theories. The purpose and extent of Cusco's underground network have generated numerous theories, each attempting to explain why the Incas invested such enormous effort in creating this subterranean realm. The sacred repository theory suggests that the tunnels served primarily as underground temples and storage areas for the empire's most precious religious artifacts. This theory draws support from Spanish chronicles that describe chambers filled with golden statues and sacred objects. Proponents argue that the Incas created this underground sanctuary to protect their most important spiritual treasures from earthquakes, wars, and other threats to the surface city. The precise engineering and decorative elements found in explored sections support this theory, suggesting that the tunnels were considered sacred spaces worthy of the same attention given to surface temples. The administrative center theory proposes that the underground network functioned as a parallel governmental complex, where the empire's administrative functions could continue uninterrupted during times of crisis. This theory points to the discovery of quipu storage areas and chambers that appear designed for meetings and record-keeping. The extensive nature of the tunnel system would have allowed administrators to move between different government departments without being observed by the general population, maintaining the mystique and authority of Inca rule. The refuge system theory suggests that the tunnels were designed as a comprehensive shelter network for the royal family and nobility during emergencies. This theory gains credibility from the discovery of chambers with ventilation systems, water sources, and storage areas that could have supported large numbers of people for extended periods. The connection between major royal compounds and temples would have allowed the elite to retreat underground while maintaining their ceremonial and governmental functions. The spiritual underworld theory proposes that the tunnels were constructed as a physical representation of Uku Pacha, the underworld realm in Inca cosmology. This theory suggests that the underground passages were designed to allow spiritual journeys between the world of the living and the realm of ancestors and spirits. The presence of mummified remains and evidence of ceremonial activities supports this interpretation, suggesting that the tunnels served as pathways for communication with the spiritual world. The hidden treasure theory, while perhaps the most sensational, maintains that the tunnels were designed specifically to conceal the empire's accumulated wealth from Spanish conquistadors. This theory argues that when the Incas realized they could not defeat the Spanish militarily, they systematically moved their gold, silver, and precious artifacts into the underground network, sealing them away until they could be safely recovered. The fact that Spanish treasure hunters spent centuries searching for this hidden wealth, and that modern explorations have found evidence of recently disturbed chambers, lends some credence to this theory. Scientific investigations. Modern technology has brought increasingly sophisticated tools to bear on the mystery of Cusco's underground network, yet each advance reveals new complexities rather than simple answers. Ground-penetrating radar mapping, conducted over the past 2 decades, has created detailed 3-dimensional images of the tunnel system. These surveys confirm that the underground network extends far beyond the historical city center, with major passages running beneath modern neighborhoods and even reaching toward the surrounding hillsides. The radar data shows that the tunnels follow a systematic plan rather than random excavation, with major thoroughfares connecting to smaller subsidiary passages in a pattern that mirrors the surface street layout of ancient Cusco. Geological analysis of exposed tunnel sections has revealed sophisticated engineering techniques that demonstrate advanced understanding of soil mechanics and structural engineering. The tunnels were carved through different types of rock and soil, with construction methods adapted to local geological conditions. In some areas, the Incas reinforced unstable soil with precisely fitted stone linings, while in others, they took advantage of natural rock formations to create chambers with minimal excavation. Archaeological excavation of accessible tunnel sections has yielded artifacts that provide clues about the underground network's functions and chronology. Pottery fragments, textile remains, and metal objects found in the tunnels span several centuries of Inca occupation, suggesting that the underground spaces remained in active use throughout the empire's existence. Carbon dating of organic materials indicates that some sections were sealed during the early colonial period, possibly as part of efforts to hide valuable objects from Spanish authorities. Environmental monitoring of tunnel conditions has revealed that the underground network maintains remarkably stable temperature and humidity levels year-round. This climate control, achieved through sophisticated ventilation and drainage systems, would have provided ideal conditions for preserving organic materials such as textiles, quipus, and mummified remains. The discovery of intact wooden structural elements and textile fragments in some chambers confirms that the tunnels have indeed provided exceptional preservation environments. Acoustic analysis of tunnel chambers has revealed that many spaces were designed with specific sound properties that would have enhanced ceremonial activities. Some chambers amplify whispered voices, while others create echoes that could have been interpreted as communications from the spirit world. These acoustic properties suggest that the tunnels served important ceremonial functions beyond simple storage or transportation. Modern challenges. The investigation and preservation of Cusco's underground network face numerous challenges that complicate both scientific study and heritage conservation efforts. Urban development pressures pose the greatest immediate threat to the tunnel system. As Cusco continues to grow, new construction projects risk damaging or destroying portions of the underground network. Foundation excavations for modern buildings have already disrupted several tunnel sections, and the installation of utilities such as water pipes and electrical cables continues to impact archaeological deposits. Balancing the city's development needs with the preservation of this underground heritage requires careful planning and constant vigilance. Flooding presents an ongoing challenge to both preservation and exploration efforts. Changes in local hydrology caused by urban development have altered groundwater flow patterns, causing some previously dry tunnel sections to flood seasonally or permanently. Climate change has intensified rainfall patterns in the region, increasing the risk of flood damage to archaeological materials preserved in the tunnels for centuries. Tourism pressure creates both opportunities and challenges for the underground network. While public interest generates support for preservation efforts and provides funding for research, it also creates pressure to open more tunnel sections to visitors. The fragile archaeological environment of the tunnels cannot withstand heavy foot traffic without significant damage, requiring careful management of any public access programs. Legal and cultural complications arise from the fact that the tunnel system extends beneath private property throughout the historical city center. Property owners have legal rights that can conflict with archaeological research needs, while some indigenous communities maintain traditional claims to certain underground spaces that they consider sacred. Negotiating these competing interests requires sensitivity and respect for all stakeholders. Security concerns limit research activities in some tunnel sections. The underground network has unfortunately attracted treasure hunters and artifact thieves who cause irreparable damage while searching for valuable objects. Some tunnel entrances have been sealed or restricted to prevent unauthorized access, limiting legitimate scientific investigation. Closing reflections. As we emerge from these shadowed depths, back into the bright Andean sunlight of modern Cusco, the mystery of the underground network seems as vast and complex as the tunnels themselves. Beneath our feet lies a parallel world that mirrors the ambitions, beliefs, and engineering genius of one of history's most remarkable civilizations. The tunnels beneath Cusco represent more than hidden architecture. They embody the Inca understanding that reality exists in multiple layers, with the visible world supported by invisible foundations. Perhaps the underground network was never meant to be fully explored or understood by outsiders, but rather to serve as a perpetual reminder that the most important truths often lie hidden beneath the surface of what we think we know. Modern Cusco continues to evolve above this ancient foundation, with millions of visitors each year walking unknowingly over chambers that may still contain treasures beyond imagination. The city's indigenous residents, many of whom are direct descendants of the tunnel builders, maintain their own relationship with this underground heritage, preserving traditions and knowledge that outside researchers are only beginning to appreciate. Each advance in technology reveals new aspects of the tunnel system, yet also highlights how much remains unknown. The underground network may ultimately prove to be larger and more complex than the surface city ever was, representing an achievement in subterranean engineering that rivals any in human history. The chambers that remain sealed may hold secrets that could revolutionize our understanding of Inca civilization, or they may be meant to remain undisturbed, continuing their silent vigil over the spiritual essence of a vanished empire. The question that haunts every exploration into these depths remains unanswered. What did the Incas place down there that was so important it required the creation of an entire shadow city? Perhaps the answer lies not in what the tunnels contain, but in what they represent: a civilization's determination to create permanence in an impermanent world, to build something that would endure beneath the surface long after the visible empire had fallen. What do you think lies hidden in the deepest chambers beneath Cusco? Share your theories in the comments below and subscribe for more ancient mysteries that continue to unfold beneath our feet. The genetic ghosts of Lake Titicaca. Picture the shores of Lake Titicaca at dawn, where mist rises from waters that have cradled civilizations for millennia. Recent DNA analysis reveals genetic patterns that shouldn't exist: European markers predating Columbus, Asian haplogroups with no clear migration path, and sequences matching no known human population. Ancient texts speak of star people emerging from the lake's depths. Could these genetic anomalies indicate unknown prehistoric migrations? Historical context. Lake Titicaca sits like a sapphire jewel in the heart of the Altiplano, straddling the border between Peru and Bolivia at an altitude of 12,500 feet above sea level. This ancient body of water, over 3 million years old, has witnessed the rise and fall of numerous civilizations, each leaving traces in both the archaeological record and the genetic heritage of local populations. The earliest known inhabitants of the Titicaca Basin were the Chiripa culture, who established settlements around the lake shores as early as 1500 BCE. These people developed sophisticated agricultural techniques, including raised field systems that allowed them to cultivate crops in the challenging high-altitude environment. Archaeological evidence suggests they possessed advanced knowledge of astronomy and mathematics, building ceremonial centers aligned with celestial events. The Tiwanaku civilization, which flourished from 300 to 1000 CE, transformed the Titicaca region into a major cultural and religious center. Their capital city, located on the lake's southern shore, featured massive stone monuments, including the famous Gate of the Sun, and precisely carved statues depicting figures with elongated skulls and distinctive facial features. Tiwanaku influence extended throughout the Andes, establishing trade networks that connected distant regions and cultures. When the Inca Empire incorporated the Titicaca region in the 15th century, they inherited a landscape already rich with sacred sites and ancient traditions. The Incas considered Lake Titicaca the birthplace of their civilization, believing that Manco Capac and Mama Ocalo, the legendary founders of their royal dynasty, emerged from the lake's waters at the command of Inti, the sun god. This origin myth was not merely symbolic. It reflected deep cultural connections to the lake that permeated every aspect of Inca society. Spanish chronicler Pedro Chiesa de León recorded local traditions describing beings who came from the sky water to teach the ancestors of the Andean peoples. These accounts, collected in the 16th century, described tall figures with pale skin and distinctive features who possessed knowledge of agriculture, astronomy, and advanced technologies. Similar stories appear in the oral traditions of multiple indigenous groups around the lake, suggesting a common source for these memories. The genetic landscape of modern Lake Titicaca populations reflects this complex history. Indigenous communities, including the Quechua, Aymara, and Uru peoples, maintain distinct cultural identities, while sharing certain genetic markers that distinguish them from other Andean populations. Traditional knowledge preserved by these communities includes detailed understanding of lake ecology, astronomical phenomena, and agricultural techniques that have sustained life in this challenging environment for millennia. Discovery. The genetic mysteries of Lake Titicaca first came to light through routine anthropological studies conducted in the 1990s. Dr. Maria Santos, a genetic anthropologist from the University of São Paulo, was collecting DNA samples from indigenous communities as part of a broader study of South American population genetics. Her initial goal was straightforward: to trace the migration patterns of early human populations throughout the continent. The first anomaly appeared in 2003, when Santos discovered mitochondrial DNA haplogroups in Uru fishermen communities that didn't match any known Native American lineages. These genetic markers, designated as haplogroup X, were previously found only in populations from the Middle East and parts of Europe. The presence of haplogroup X in pre-Columbian American populations had been documented elsewhere, but never at the frequencies observed around Lake Titicaca. More puzzling discoveries emerged when Santos expanded her sampling to include Aymara communities on the Bolivian side of the lake. Carbon dating of archaeological sites suggested these populations had been present in the region for over 2,000 years. Yet their genetic signatures included markers typically associated with East Asian populations. These haplogroups showed no evidence of recent admixture, indicating they had been present in the local gene pool for many generations. The most startling revelation came in 2008, when advanced DNA sequencing techniques revealed genetic sequences that couldn't be matched to any reference populations in global databases. These orphan sequences appeared in approximately 12% of individuals tested from specific communities around the lake's sacred islands. The sequences were clearly human, but they represented genetic lineages that seemed to have no close relatives anywhere else in the world. International attention focused on the Lake Titicaca genetic anomalies in 2012, when Dr. James Richardson from Oxford University independently confirmed Santos's findings. Richardson's team expanded the geographic scope of testing, collecting samples from remote communities throughout the Titicaca Basin. Their results not only validated the presence of anomalous genetic markers, but revealed that the highest concentrations occurred in communities with the strongest traditions of contact with sky-water beings. The genetic discoveries gained additional significance when researchers began correlating DNA patterns with oral histories collected from indigenous communities. Families carrying the most unusual genetic markers often possess the most detailed traditional knowledge about astronomical phenomena and advanced agricultural techniques. This correlation suggested possible connections between genetic heritage and the preservation of ancient knowledge systems. Theories. The genetic anomalies observed in Lake Titicaca populations have generated numerous theories, each attempting to explain how such unusual patterns could have emerged in this isolated, high-altitude environment. The lost migration theory proposes that the genetic anomalies result from previously unknown prehistoric migrations that brought diverse populations to the Lake Titicaca region. This theory suggests that ancient sea routes or overland passages allowed groups from the Middle East, Asia, and possibly other regions to reach South America thousands of years before Columbus. Proponents point to archaeological evidence of sophisticated navigation techniques among ancient maritime cultures and argue that current models of human migration may be incomplete. The isolated refuge theory suggests that Lake Titicaca served as a genetic refuge where small populations with unique genetic characteristics survived in isolation for thousands of years. The lake's high altitude and challenging environment may have created conditions that preserved rare genetic lineages while they disappeared from other populations. This theory explains the presence of orphan genetic sequences as remnants of ancient human diversity that was lost elsewhere due to genetic drift and population bottlenecks. The cultural transmission theory proposes that the genetic anomalies are linked to cultural practices that influenced mate selection and population structure over many generations. Communities that preserved specific traditions and knowledge systems may have maintained distinct genetic characteristics through cultural mechanisms. This theory suggests that the correlation between genetic markers and traditional knowledge reflects deep cultural continuity rather than extraordinary migration events. The environmental adaptation theory argues that the unique genetic patterns result from evolutionary adaptations to the extreme conditions around Lake Titicaca. High altitude, intense solar radiation, and limited oxygen availability may have selected for specific genetic variants that improved survival in this environment. Some of these adaptive mutations might have produced genetic signatures that appear anomalous when compared to sea-level populations, but represent successful evolutionary responses to local conditions. The ancient contact theory, while more speculative, suggests that the genetic anomalies and associated cultural knowledge indicate contact with technologically advanced populations in the distant past. This theory draws connections between the unusual genetic markers, the sophisticated astronomical and agricultural knowledge preserved in local traditions, and the widespread legends of sky-water beings who taught ancient peoples. While lacking direct evidence, this theory attempts to provide a unified explanation for multiple unexplained phenomena in the Lake Titicaca region. Scientific investigations. Modern genetic research has brought increasingly sophisticated analytical tools to bear on the Lake Titicaca mystery. Yet each advance seems to deepen rather than resolve the puzzle. Whole genome sequencing, conducted by international research consortiums, has provided detailed genetic profiles of individuals carrying anomalous markers. These comprehensive analyses reveal that the unusual genetic characteristics are not recent mutations, but represent ancient lineages that diverged from known human populations thousands of years ago. The patterns suggest multiple founding events rather than single migration episodes, indicating a complex population history that current models cannot fully explain. Comparative genetic analysis using global reference databases has failed to identify close relatives for the orphan genetic sequences found around Lake Titicaca. Despite having access to genetic data from thousands of populations worldwide, researchers have been unable to trace the geographic origins of these unique lineages. This absence of genetic relatives suggests either that the source populations have disappeared or that they exist in regions not yet sampled by genetic surveys. Archaeological genetics, combining DNA analysis with radiocarbon dating of human remains, has confirmed that anomalous genetic markers were present in the Lake Titicaca region at least 2,000 years ago. Analysis of mummified remains from Tiwanaku period burials shows genetic continuity with modern populations carrying unusual markers, indicating stable transmission of these characteristics over many generations. Population genetics modeling has attempted to reconstruct the demographic history of Lake Titicaca communities using computational simulations. These models consistently indicate that the current genetic diversity patterns require multiple founding populations arriving at different times, followed by periods of isolation and limited gene flow. However, the models cannot specify the geographic origins or migration routes of these founding populations. Epigenetic research has revealed that individuals carrying anomalous genetic markers also show distinctive patterns of gene expression related to high-altitude adaptation and cognitive function. These epigenetic modifications appear to enhance performance in low-oxygen environments and may be associated with the preservation of complex cultural knowledge systems. The relationship between genetic variants and epigenetic patterns suggests sophisticated biological mechanisms for adaptation to extreme environments. Modern challenges. The investigation of genetic mysteries around Lake Titicaca faces numerous challenges that complicate both research efforts and the preservation of unique genetic heritage. Climate change poses immediate threats to the traditional communities that preserve both genetic diversity and associated cultural knowledge. Rising temperatures and changing precipitation patterns are altering the lake ecosystem, forcing communities to abandon traditional subsistence practices and migrate to urban areas. This disruption threatens to scatter genetically unique populations and break the transmission of traditional knowledge that has been preserved for generations. Ethical considerations surrounding genetic research on indigenous populations have become increasingly complex as the implications of the findings become clearer. Communities that have provided DNA samples for research may not have fully understood the potential significance of their genetic heritage. Questions arise about ownership of genetic information, commercial applications of research findings, and the rights of communities to control how their genetic data is used. Sample preservation and storage present ongoing technical challenges as researchers attempt to maintain genetic material collected over several decades. DNA degradation, contamination, and the need for increasingly sophisticated analytical techniques require continuous investment in laboratory infrastructure and trained personnel. Limited funding for long-term research programs threatens the continuity of studies needed to fully understand the genetic patterns. Cultural sensitivity issues have emerged as research findings challenge conventional understanding of human migration and population history. Some interpretations of the genetic data conflict with traditional origin stories maintained by indigenous communities, creating tension between scientific inquiry and cultural preservation. Researchers must navigate these conflicts while maintaining respect for indigenous perspectives and rights. International collaboration faces obstacles due to political tensions and bureaucratic complications associated with cross-border research in the Lake Titicaca region. Samples and data sharing between Peruvian and Bolivian institutions requires complex legal agreements, while indigenous communities maintain their own protocols for research participation that must be honored by all parties. Closing reflections. As dawn breaks over Lake Titicaca's sacred waters, the genetic ghosts haunting these shores seem more mysterious than ever. Each scientific advance reveals new complexities in the human story written in DNA sequences that challenge our understanding of prehistoric South American populations. The greatest mystery may lie not in where these unique genetic lineages originated, but in what they preserved during their isolation in this high-altitude sanctuary. The correlation between genetic markers and traditional knowledge suggests human diversity encompasses more than physical characteristics. It includes irreplaceable intellectual and cultural heritage. The sky-water beings, remembered in local traditions, may represent real historical encounters that left traces in both genetic heritage and cultural memory. Whether these contacts involved unknown human populations, environmental adaptations, or something beyond current scientific understanding, they remind us that human history contains chapters we are only beginning to read. The mist rising each morning from Lake Titicaca may carry more than moisture. It may carry the breath of ancestral populations whose genetic legacy challenges everything we thought we knew about human migration. As we peer through this mist toward an increasingly complex past, we must remain open to possibilities that transcend current scientific paradigms. What do you think explains the genetic mysteries preserved in Lake Titicaca's high-altitude communities? Share your theories in the comments below, and subscribe for more ancient mysteries that continue to reshape our understanding of human history. The resonance chambers of Machu Picchu. Envision standing in Machu Picchu's Temple of the Sun as dawn breaks over the ancient city, sensing something invisible yet powerful flowing through these stones. Acoustic engineers have discovered that certain chambers exhibit sound properties that seem impossible for their architecture. Whispers in the Temple of the Condor carry across vast distances, while other rooms absorb sound completely, creating zones of absolute silence. Most intriguingly, some chambers produce infrasonic frequencies that can induce altered states of consciousness. Were these acoustic properties accidental? Historical context. Machu Picchu stands as one of humanity's most remarkable architectural achievements, perched on a mountain ridge 8,000 feet above sea level in the Peruvian Andes. Built during the reign of Inca Emperor Pachacuti around 1450, this royal estate was more than a summer palace. It was a sacred center where the physical and spiritual worlds intersected through sophisticated engineering and astronomical alignments. The site's construction required moving massive granite blocks up treacherous mountain slopes, using techniques that continue to puzzle modern engineers. Yet the Incas achieved something even more remarkable than logistical mastery. They created structures that seem to harness and manipulate sound waves in ways that suggest deep understanding of acoustic principles that weren't formally recognized in Western science until centuries later. Inca civilization possessed sophisticated knowledge of sound and its effects on human consciousness. Their religious ceremonies incorporated specific musical instruments, chants, and architectural spaces designed to create transcendent experiences. The concept of Aini, or reciprocal harmony between humans and the natural world, extended to sonic environments, where architectural acoustics were understood as living forces that could facilitate communication with spiritual realms. The architects of Machu Picchu integrated acoustic considerations into every aspect of the site's design. The Temple of the Sun was positioned to capture not only celestial alignments, but also specific sound reflections from surrounding peaks. The Intihuatana stone, often called a solar clock, may have functioned equally as a sonic focal point where sound waves converged from multiple directions. Even the agricultural terraces were constructed with stone arrangements that influenced how sounds traveled across the site. Spanish chroniclers noted that Inca priests possessed knowledge of sound manipulation that seemed almost supernatural. Pedro Cieza de Leon described ceremonies where whispered words could be heard clearly across vast plazas, and where certain spaces induced profound altered states in participants. These accounts suggested that Inca acoustic engineering went far beyond simple architectural considerations to encompass sophisticated understanding of sound's psychological and spiritual effects. The abandonment of Machu Picchu around 1572 meant that its acoustic secrets remained undisturbed for centuries. When Hiram Bingham brought international attention to the site in 1911, the focus remained on its architectural and archaeological significance. The subtle but profound acoustic properties that may have been central to the site's original function went largely unnoticed until modern scientific instruments could measure what ancient ears had experienced. Discovery. The acoustic mysteries of Machu Picchu first came to scientific attention through accident rather than systematic investigation. In 1995, Dr. Susan Chavez, an archaeoacoustics researcher from the University of California, was conducting routine documentation of Andean archaeological sites when her sound recording equipment detected unusual acoustic phenomena at Machu Picchu. Chavez discovered that the Temple of the Condor exhibited extraordinary sound amplification properties. Whispered conversations at one end of the structure could be heard clearly at distances that should have been impossible given the temple's open architecture. Initial measurements suggested that the carefully arranged stones were creating acoustic focusing effects, similar to those found in deliberately designed concert halls and amphitheaters. More intriguing discoveries emerged when Chavez expanded her investigations to other structures throughout the site. The Princess Palace contained chambers where sound seemed to disappear entirely, creating zones of such complete acoustic dampening that even shouted words became barely audible. These silence chambers appeared to absorb sound waves so effectively that they created sensory environments unlike anything found in nature. The most startling revelation came during pre-dawn recording sessions, when Chavez detected infrasonic frequencies emanating from certain underground spaces within Huayna Picchu, the steep peak that towers over the main ruins. These sound waves, below the range of human hearing, registered consistently at precisely 110 Hz, a frequency that neuroscience research had recently identified as capable of inducing altered states of consciousness and enhanced spiritual experiences. International attention focused on Machu Picchu's acoustic properties in 2003 when acoustic engineer Dr. Paulo de Bertolis from the University of Trieste conducted comprehensive sound mapping of the entire site. De Bertolis' team used advanced measurement equipment to document acoustic characteristics of over 30 different structures, revealing that the site contained the most sophisticated collection of acoustic architecture ever discovered in the ancient world. The research revealed that Machu Picchu's acoustic properties were not random effects, but part of a comprehensive sonic landscape designed to create specific psychological and spiritual states. Different areas of the site produced distinct acoustic environments, some energizing and stimulating, others calming and meditative. The overall effect suggested that visitors moving through the site would experience a carefully orchestrated sonic journey that enhanced their spiritual and ceremonial experiences. Perhaps most remarkably, the acoustic properties appeared to be specifically tuned to human physiology, frequencies that enhanced meditation, promoted healing, and facilitated transcendent experiences were precisely calibrated and strategically positioned throughout the site. This level of acoustic sophistication suggested that Inca architects possessed understanding of sound's effects on human consciousness that modern science is only beginning to appreciate. Theories. The sophisticated acoustic properties discovered throughout Machu Picchu have generated numerous theories attempting to explain how ancient architects achieved such advanced sound manipulation without modern technology or scientific understanding. The intentional acoustic design theory proposes that Inca architects deliberately incorporated acoustic considerations into every aspect of Machu Picchu's construction. This theory suggests that builders possessed empirical knowledge of sound wave behavior gained through centuries of experimentation with stone arrangements and architectural geometries. Proponents argue that the consistent presence of specific acoustic effects across multiple structures indicates systematic application of acoustic principles rather than accidental discoveries. The natural resonance amplification theory suggests that Inca builders identified and amplified natural acoustic properties inherent in the site's geographical features. The mountainous terrain, granite composition, and atmospheric conditions at Machu Picchu's altitude create unique sound propagation characteristics that skilled architects could enhance through strategic stone placement. This theory explains the acoustic effects as sophisticated engineering that worked with rather than against natural sound phenomena. The ceremonial consciousness manipulation theory proposes that the acoustic properties were designed specifically to alter participants' mental states during religious ceremonies. The precise tuning of infrasonic frequencies to neurologically active ranges suggests deliberate intention to induce transcendent experiences, facilitate communication with spiritual realms, and enhance the psychological impact of ceremonial activities. This theory connects acoustic engineering with Inca spiritual practices and cosmological beliefs. The geological acoustic interaction theory suggests that Machu Picchu's architects understood how different stone types and geological formations interact with sound waves. The site's construction materials include various granite compositions that exhibit different acoustic properties when arranged in specific configurations. This theory proposes that builders selected and positioned stones based on their individual acoustic characteristics to create desired sound effects. The advanced ancient knowledge theory, while more speculative, suggests that Inca acoustic engineering derived from sophisticated scientific understanding that equaled or exceeded modern acoustics knowledge. This theory points to the precision of acoustic effects, the integration with astronomical alignments, and the apparent understanding of sound's neurological impacts as evidence of advanced scientific capabilities that may have been developed independently or inherited from earlier civilizations. Scientific investigations. Modern scientific analysis of Machu Picchu's acoustic properties has employed increasingly sophisticated measurement techniques, revealing layers of complexity that continue to challenge conventional understanding of ancient engineering capabilities. Frequency spectrum analysis, using precision sound measurement equipment, has documented the exact acoustic characteristics of each structure throughout the site. These measurements confirm that different areas produce distinctly different sonic environments, with frequency responses that appear specifically tuned to human auditory and neurological systems. The precision of these acoustic effects suggests deliberate design rather than accidental architectural consequences. Infrasonic monitoring equipment has detected consistent low-frequency emissions from underground chambers and certain stone arrangements. These sound waves, while inaudible to human ears, register on sensitive instruments and occur at frequencies known to influence human consciousness and emotional states. The consistency of these emissions across different weather conditions and times of day indicates that they result from architectural features rather than environmental factors. Three-dimensional acoustic modeling, using computer simulations, has reconstructed how sound waves interact with Machu Picchu's architecture. These models reveal that the stone arrangements create complex sound reflection and resonance patterns that amplify certain frequencies while dampening others. The mathematical precision of these acoustic effects suggests sophisticated understanding of wave physics and architectural acoustics. Neurological response studies have examined how people's brain activity changes when exposed to the specific frequencies detected at Machu Picchu. EEG monitoring shows that the infrasonic emissions can indeed induce altered brainwave patterns associated with meditative states, enhanced creativity, and spiritual experiences. These findings support theories that the acoustic properties were designed to facilitate transcendent consciousness. Geological acoustic analysis has investigated how the site's granite foundation and surrounding mountain terrain contribute to the acoustic effects. The research reveals that the stone composition and geological structure create natural resonance chambers that the Inca architects enhanced through strategic construction techniques. This analysis helps explain how the acoustic effects were achieved using available materials and natural phenomena. Materials analysis of the stones used in acoustically active structures has revealed subtle differences in granite composition that correlate with specific acoustic properties. Certain stones appear to have been selected specifically for their acoustic characteristics rather than purely structural considerations. This finding suggests that Inca builders possessed detailed knowledge of how different materials influenced sound propagation. Modern challenges. The preservation and study of Machu Picchu's acoustic properties face numerous challenges that threaten both the physical integrity of the structures and our ability to understand their sonic functions. Tourism impact poses the greatest immediate threat to the site's acoustic environment. With over 1 million visitors annually, the constant foot traffic, voices, and modern noise pollution interfere with the subtle acoustic effects that ancient architects so carefully created. The presence of large crowds fundamentally alters the sonic landscape, making it difficult to experience or study the site's original acoustic properties. Structural degradation caused by weather, seismic activity, and age threatens the precise stone arrangements that create the acoustic effects. Even minor shifts in stone position can dramatically alter sound wave interactions, potentially destroying acoustic properties that have been preserved for centuries. Conservation efforts must balance structural preservation with maintaining the acoustic integrity of the arrangements. Climate change has brought more extreme weather patterns to the high Andes, including increased rainfall, temperature fluctuations, and severe storms that accelerate erosion of the precisely fitted stones. These environmental changes threaten not only the physical structures, but also the acoustic spaces between and within them that are essential to the sound effects. Research limitations arise from restrictions on invasive investigation techniques that might damage the site while providing scientific data. Non-invasive measurement methods, while respectful of the site's integrity, limit the depth of acoustic analysis that researchers can conduct. Balancing scientific investigation with preservation requirements requires careful coordination and innovative research approaches. Modern infrastructure development around Machu Picchu, including helicopter flights, construction equipment, and electronic systems, creates acoustic pollution that interferes with both research activities and visitor experiences. The intrusion of contemporary sounds makes it increasingly difficult to appreciate the subtle acoustic environment that the site's builders created. Legal and cultural considerations affect research permissions and methodologies. Indigenous communities maintain spiritual connections to Machu Picchu that must be respected in any scientific investigation. Research protocols must acknowledge these cultural perspectives while pursuing scientific understanding of the site's acoustic properties. Closing reflections. As morning mist clears from Machu Picchu's ancient stones, we contemplate mysteries extending far beyond what the eye can see. The invisible symphony flowing through these granite blocks speaks to capabilities that challenge our understanding of ancient civilizations. The acoustic properties suggest Inca architects understood sound not merely as physical phenomenon, but as a bridge between material and spiritual worlds. Their ability to manipulate frequencies that influence human consciousness implies knowledge that modern science is only beginning to appreciate. Perhaps the most profound mystery lies not in how these acoustic effects were created, but why they were considered so important. The enormous investment to achieve specific sonic environments suggests that sound played a central role in Machu Picchu's spiritual functions that we are only beginning to understand. Each whisper that carries impossibly far, each moment of perfect silence, each infrasonic pulse from Huayna Picchu's depths continues, demonstrating that our ancestors possessed wisdom transcending current scientific paradigms. These acoustic ghosts remind us that human achievement encompasses more than visible monuments. It includes invisible mastery of forces that shape consciousness itself. The stones continue to sing their ancient songs, waiting for us to develop ears sensitive enough to hear all the frequencies of wisdom they contain. In learning to listen to these acoustic messages from the past, we might discover how sound can continue to transform human experience in ways we have yet to explore. What do you think the Inca architects hope to achieve through their sophisticated acoustic engineering? Share your theories in the comments below and subscribe for more ancient mysteries that continue to resonate through time. The Vanished Children of Lulailaco. Imagine ascending a sacred peak where the air grows thin and the boundary between earth and sky dissolves, where 3 children were found in a state of preservation so perfect they seemed to sleep rather than rest in eternal slumber. On Lulailaco, Argentina's highest volcano, these young people were discovered in 1999, their bodies naturally mummified by extreme altitude and cold. Toxicology reveals they consumed massive amounts of coca and chicha before their sacrifice, yet their faces show no signs of distress. Most puzzling, isotope analysis suggests they traveled vast distances in their final months, participating in a pilgrimage spanning the empire. What drew the Incas to practice these high-altitude ceremonies? And why do these children appear so serene in death? Historical context. Lula-Ilaco volcano rises 22,110 feet above sea level, straddling the border between Argentina and Chile. This towering peak held profound significance in Inca cosmology as one of the Apu, sacred mountain spirits that governed the natural world and served as intermediaries between humans and the divine realm of Hanan Pacha. The practice of capachocha, or ritual sacrifice at high-altitude sacred sites, represented one of the most solemn ceremonies in Inca religion. These offerings were not acts of brutality but profound spiritual transactions, where carefully selected children were believed to become eternal guardians of the empire, transforming into sacred ancestors who could intercede with the gods on behalf of their people. The Inca Empire conducted capacocha ceremonies during times of imperial crisis, natural disasters, or significant political transitions. The selection process was extraordinarily selective, with children chosen for their physical perfection, noble lineage, and spiritual purity. These young people were considered blessed rather than victims, destined for transformation into powerful spiritual beings who would protect the empire from cosmic threats. The journey to high-altitude sacrifice sites like Lula-Ilaco was itself a sacred pilgrimage that could span months and cover thousands of miles. Children selected for capachocha were taken from their families and prepared through elaborate ceremonies that gradually elevated their spiritual status. They were dressed in the finest textiles, adorned with precious metals and gems, and treated as living deities during their final months. Spanish chroniclers documented the reverence surrounding capacocha ceremonies, noting that communities considered it the highest honor to have their children selected. The rituals were conducted with such solemnity and spiritual preparation that participants entered altered states of consciousness that may have transcended ordinary human experience of death and transformation. Archaeological evidence suggests that Lula-Ilaco was used for ceremonial purposes for centuries before the final Inca period. The extreme altitude and harsh conditions created a natural temple environment where the boundary between the physical and spiritual worlds seemed to dissolve, making it an ideal location for the most sacred of Inca ceremonies. Discovery. The discovery of the Lula-Ilaco children began with a routine archaeological survey in 1995, when Argentine archaeologist Dr. Johann Reinhardt was investigating Inca ceremonial sites throughout the high Andes. Reinhardt had previously discovered several child mummies at other peaks, but Lula-Ilaco presented unique challenges due to its extreme altitude and harsh weather conditions. The expedition to Lula-Ilaco required extensive preparation, including acclimatization climbs and specialized high-altitude equipment. At over 22,000 feet, the summit exists in what mountaineers call the death zone, where oxygen levels drop to barely one-third of sea level concentrations. These conditions, while deadly to living humans, created perfect preservation environments for organic materials. The first discovery came on March 13, 1999, when Reinhardt's team located a rectangular stone platform near the volcano's summit. Careful excavation revealed a burial chamber containing the perfectly preserved body of a young girl, approximately 15 years old, who became known as La Doncella, or the Maiden. Her preservation was so remarkable that she appeared to be sleeping rather than dead. Further exploration revealed two additional burial sites nearby, containing the bodies of a younger girl, approximately 6 years old, and a boy of around 7 years. All three children were found in seated positions, wrapped in elaborate textiles, and surrounded by precious grave goods, including gold and silver figurines. feathered headdresses, and decorated pottery. The preservation conditions at Lulalaco exceeded anything previously encountered in Andean archaeology. The extreme cold, low humidity, and high altitude had created natural freeze-drying conditions that preserved not only the children's bodies, but also their clothing, hair, skin, and internal organs with extraordinary detail. Initial examination revealed that the children had died approximately 500 years ago, during the height of the Inca Empire. Their clothing and grave goods confirmed their high status within Inca society, while their physical condition suggested they had been healthy and well-nourished throughout their lives, indicating careful preparation for their final ceremony. Theories. The circumstances surrounding the Lulalaco children have generated numerous theories attempting to explain both the purpose of these high-altitude sacrifices and the remarkable serenity evident in the children's preserved remains. The imperial crisis theory suggests that the Capachocha ceremony at Lulalaco was conducted in response to a specific threat to the Inca Empire, possibly the arrival of Spanish conquistadors or internal political upheaval. This theory proposes that the children were offered as spiritual protection against existential dangers that threatened the survival of Inca civilization. The timing of their deaths, around 1500 to 1520, coincides with the period of Spanish contact and the beginning of imperial collapse. The cosmic alignment theory proposes that the ceremony was timed to coincide with specific astronomical events that held profound significance in Inca cosmology. The positioning of the burial sites and the orientation of the children's bodies suggest careful consideration of celestial alignments. This theory suggests that the children were offered during a cosmic moment, when communication between earthly and divine realms was believed to be most effective. The voluntary transformation theory suggests that the children participated willingly in their own transformation, understanding their role as spiritual intermediaries and accepting their fate as a sacred honor. This theory draws support from the absence of trauma or signs of struggle in the children's remains, suggesting they entered death peacefully. The high levels of coca and chicha found in their systems may have induced transcendent states that facilitated this willing transition. The shamanic journey theory proposes that the children underwent profound spiritual preparation that enabled them to transcend normal human consciousness and experience death as a transformation rather than an ending. This theory suggests that Inca priests possessed sophisticated knowledge of consciousness manipulation through combinations of altitude, drugs, and ritual practices that could induce mystical experiences. The environmental adaptation theory offers a more pragmatic explanation, suggesting that the children were gradually adapted to high-altitude conditions through careful preparation that made their final journey less traumatic. Their remarkably preserved condition and peaceful expressions could result from this physiological preparation, combined with the natural preservation effects of the extreme environment. Scientific investigations. Modern scientific analysis of the Lulalaco children has employed cutting-edge techniques that reveal unprecedented detail about their lives, deaths, and the circumstances of their final ceremony. CT scanning and magnetic resonance imaging have provided detailed views of the children's internal organs, revealing that their preservation extends throughout their bodies, rather than being limited to external tissues. These scans show intact brain tissue, organs, and even stomach contents, allowing researchers to reconstruct their final meals and physical condition at the time of death. Toxicological analysis of hair samples has revealed the presence of significant quantities of coca alkaloids and alcohol metabolites, indicating consumption of coca leaves and chicha corn beer during their final months. The pattern of drug presence suggests gradual increases in consumption leading up to their deaths, supporting theories about systematic preparation for the ceremony. Isotope analysis of teeth and hair has traced the children's geographic movements during their final year of life. The isotopic signatures found in their remains indicate they traveled from distant regions of the empire, possibly from as far away as Cusco or the coastal regions of Peru. This evidence supports accounts of Capasocha ceremonies involving extensive pilgrimages. DNA analysis has provided information about the children's ancestry and family relationships. The results indicate they came from different regions of the Inca Empire, suggesting that children were selected from various provinces for these ceremonies. Genetic markers also reveal information about their health, status, and potential relationships to other Andean populations. Textile analysis of the children's clothing has revealed sophisticated weaving techniques and materials that indicate their high status. The fabrics include vicuña wool, alpaca fiber, and cotton, some dyed with precious pigments and decorated with gold and silver threads. The construction techniques and materials used represent the finest examples of Inca textile production. Radiographic examination has revealed that the children suffered no trauma or violence, supporting theories that their deaths were peaceful rather than traumatic. The positioning of their bodies and the absence of defensive wounds or signs of struggle suggest they may have been unconscious or in altered states of consciousness when they died. Modern challenges. The preservation and study of the Lulailako children present unique challenges that span ethical, technical, and cultural considerations. Conservation of the remarkably preserved remains requires specialized storage conditions that maintain the low temperature and humidity that preserve them for centuries. The children are currently housed in specially designed cryogenic chambers that replicate the environmental conditions of their mountain tomb, but maintaining these conditions requires constant technical monitoring and significant resources. Ethical considerations surrounding the study of the children have become increasingly complex as understanding of indigenous rights and cultural sensitivity has evolved. Questions arise about the appropriateness of displaying human remains, even for scientific and educational purposes, particularly when those remains belong to cultures whose descendants maintain active spiritual relationships with their ancestors. Cultural sensitivity issues have emerged as indigenous communities throughout the Andes have expressed concerns about the treatment of the children's remains. Some groups argue that the children should be reburied according to traditional practices, while others support continued study that might provide insights into their ancestral cultures. International legal complications affect the ownership and custody of the remains, as they were discovered in Argentina, but represent children from the broader Inca Empire that encompassed multiple modern nations. Questions of cultural patrimony and repatriation rights involve complex negotiations between governments and indigenous communities. Climate change poses long-term threats to other high-altitude archaeological sites throughout the Andes, as rising temperatures and changing precipitation patterns threaten to damage or destroy similar discoveries before they can be properly studied. The Lulailako children may represent the best preserved examples of a broader archaeological record that is increasingly at risk. Funding limitations restrict the scope of research that can be conducted on the children and similar discoveries. The specialized equipment and expertise required for studying high-altitude mummies is expensive, while the international nature of the research requires coordination between multiple institutions and funding agencies. Closing reflections. As we contemplate the serene faces of the Lulailako children, preserved in their eternal sleep, high above the clouds, we encounter mysteries that transcend our modern understanding of life, death, and the sacred bonds between humans and the natural world. These three young people, chosen for reasons we can only partially comprehend, embarked on a journey that carried them from their home communities across vast distances to one of Earth's most extreme environments. Their peaceful expressions and perfect preservation speak to experiences that may have transcended ordinary human consciousness, suggesting that their final ceremony involved spiritual dimensions we struggle to appreciate. The remarkable preservation of their bodies offers us an unprecedented window into Inca civilization at its height, revealing the sophisticated knowledge and profound spiritual beliefs that motivated one of history's most complex societies. Yet each scientific discovery seems to deepen rather than resolve the fundamental mysteries surrounding their lives and deaths. Perhaps the most profound question is not why these children were chosen for sacrifice, but what they experienced during their transformation from living beings to eternal guardians. Their serene expressions suggest they may have achieved a state of consciousness that transcended fear and pain, entering death as a doorway to spiritual transformation rather than an ending. The children of Lulailako continue to serve as bridges between worlds, ancient and modern, scientific and spiritual, life and death. They remind us that human experience encompasses dimensions that our technological civilization has perhaps forgotten, and that the boundaries we perceive between life and death may be less absolute than we assume. In their perfect preservation and peaceful repose, these children offer us glimpses of a worldview that saw death not as termination, but as transformation, and that understood the sacred relationship between humans and the towering peaks that touch the sky. They remain eternal witnesses to the complexity and mystery of human spiritual experience. What do you think the Lulailako children experienced during their final journey to the sacred peak? Share your thoughts in the comments below, and subscribe for more ancient mysteries that continue to challenge our understanding of human experience and spiritual transformation. The floating gardens that defied physics. Picture vast terraces carved into impossible mountainsides, where water flows upward against gravity and crops grow in soil that shouldn't exist at such altitudes. Throughout the Inca Empire, agricultural terraces called andens demonstrate water management techniques that modern engineers struggle to replicate. At sites like Moray, circular terraces create microclimates varying by dozens of degrees within a few hundred meters, allowing tropical crops to grow at highland elevations. The irrigation systems transport water across valleys and up mountainsides without pumps, using principles that seem to violate basic hydrology. Some terraces continue functioning perfectly after 500 years of abandonment, while others mysteriously ceased working when the Incas departed. Did the Incas understand atmospheric pressure and fluid dynamics at a level surpassing contemporary civilizations, or were they employing techniques that modern physics hasn't yet explained? Historical context. The Inca Empire, spanning over 2,500 miles along the spine of South America, faced an agricultural challenge unlike any civilization before or since. From the coastal deserts of Peru to the high-altitude plateaus of Bolivia, the empire encompassed virtually every climate and elevation zone imaginable, yet somehow managed to feed a population estimated at 12 million people. The solution lay in a revolutionary approach to agriculture that transformed the Andean landscape into a vast network of terraced gardens that seemed to defy the laws of nature. These agricultural systems, called andenes in Quechua, were not simply carved steps on mountainsides, but sophisticated engineering marvels that created entirely new ecological environments in places where crops should never have survived. The Andes represented the culmination of thousands of years of Andean agricultural innovation. Pre-Inca cultures, including the Chavin, Moche, and Tiwanaku, had developed terrace farming techniques, but the Incas elevated these methods to unprecedented levels of sophistication and scale. At the height of their empire, they maintained over 1 million hectares of terraced agricultural land, much of it at altitudes and angles that modern agriculture considers impossible. The terraces were constructed using principles that integrated hydrology, soil science, climatology, and plant biology in ways that created self-sustaining agricultural ecosystems. Each terrace level was carefully engineered with specific soil compositions, drainage systems, and microclimatic conditions that allowed different crops to thrive at their optimal growing conditions, even when those conditions differed dramatically from the surrounding natural environment. The most remarkable aspect of Inca agricultural engineering was their ability to transport water to seemingly impossible locations. Springs and streams were captured high in the mountains and channeled through elaborate stone conduits that carried water across valleys, around cliffs, and up steep slopes to reach terraces that appeared to float impossibly on vertical mountainsides. The hydraulic engineering required to achieve these effects involved understanding principles of fluid dynamics that weren't formally recognized in European science until centuries later. The Incas somehow mastered techniques for using atmospheric pressure, siphon effects, and gravitational flow patterns to move water in ways that appeared to violate basic physics. Discovery. The rediscovery of Inca hydraulic engineering began in the early 20th century, when American explorer Hiram Bingham documented the agricultural terraces surrounding Machu Picchu. Bingham was primarily focused on the architectural achievements of the site, but he noted that many of the terraces still retained water and showed signs of recent cultivation despite centuries of abandonment. The true sophistication of Inca agricultural engineering didn't become apparent until the 1970s, when Peruvian archaeologist Dr. Ann Kendall began systematic studies of terrace systems throughout the former Inca territory. Kendall's research revealed that the terraces represented far more than simple slope modification. They were complex environmental engineering systems that created artificial ecosystems. The most startling discoveries emerged at sites like Moray, where circular terraces descend into the earth like enormous amphitheaters. Initial surveys suggested these were ceremonial sites, but temperature monitoring revealed that they functioned as agricultural laboratories where microclimates with temperature differences of up to 30 degrees Fahrenheit existed within a few hundred meters of each other. In 1985, hydraulic engineer Dr. Charles Ortloff began detailed analysis of Inca water management systems using modern engineering principles. Ortloff discovered that the Incas had developed techniques for moving water that challenged conventional understanding of fluid dynamics. Some irrigation channels appeared to carry water uphill for considerable distances without any visible pumping mechanism. Computer modeling of the water flow patterns revealed that the Incas had somehow harnessed atmospheric pressure differentials and carefully calculated gravitational effects to create self-powered hydraulic systems. These systems used principles that weren't formally understood in Western science until the development of advanced fluid dynamics in the 20th century. Perhaps most mysteriously, many of these systems ceased to function when the Spanish conquered the Inca Empire, even though the physical infrastructure remained intact. Some terraces that had operated continuously for centuries suddenly dried up when their Inca operators disappeared, suggesting that their function depended on maintenance techniques or knowledge that was lost with the empire's collapse. Theories. The seemingly impossible hydraulic achievements of Inca agriculture have generated numerous theories attempting to explain how ancient engineers accomplished feats that challenge modern understanding of physics and engineering. The advanced empirical knowledge theory proposes that Inca engineers developed sophisticated understanding of fluid dynamics through centuries of experimentation and observation. This theory suggests that while they may not have possessed formal scientific theories, they had accumulated practical knowledge of atmospheric pressure, siphon effects, and gravitational flow patterns that allowed them to design systems that modern engineers find difficult to explain or replicate. The atmospheric pressure manipulation theory suggests that the Incas understood how to use altitude and atmospheric pressure differentials to move water in ways that appeared to defy gravity. At high altitudes where many terrace systems operated, atmospheric pressure is significantly lower than at sea level, creating conditions where water can be moved through carefully designed conduits using pressure differentials that wouldn't be effective at lower elevations. The biological engineering theory proposes that Inca agricultural systems incorporated living components that contributed to their hydraulic function. This theory suggests that specially selected plants, soil microorganisms, and even carefully managed animal populations were integrated into the terrace systems in ways that enhanced water retention, distribution, and purification. The loss of these biological components when the systems were abandoned could explain why many ceased to function. The acoustic water manipulation theory offers a more speculative explanation, suggesting that the Incas used sound waves to influence water flow patterns. Some researchers have noted that certain terrace systems incorporate stone arrangements that create acoustic effects, and have proposed that specific sound frequencies might have been used to enhance water movement or distribution through mechanisms not yet understood by modern physics. The quantum field effect theory, while highly speculative, suggests that Inca engineers somehow understood and manipulated quantum mechanical effects that influence fluid behavior at microscopic scales. This theory proposes that the precise stone arrangements and geometric patterns found in terrace systems might create coherent quantum field effects that influence water molecular behavior in ways that macroscopic physics cannot predict. Scientific investigations. Modern scientific analysis of Inca hydraulic systems has employed increasingly sophisticated measurement and modeling techniques, yet many aspects of their function remain unexplained by conventional engineering principles. Hydrological modeling using computer simulations has attempted to recreate the flow patterns observed in Inca irrigation systems. These models consistently show that many of the systems should not function according to conventional fluid dynamics, yet archaeological evidence confirms that they operated effectively for centuries. The discrepancy between theoretical predictions and historical performance suggests that the Incas employed principles or techniques not accounted for in standard hydrological models. Ground-penetrating radar surveys have revealed the full extent of underground water management infrastructure associated with terrace systems. These surveys show extensive networks of buried channels, reservoirs, and control structures that are far more complex than surface observations suggest. The sophistication of this hidden infrastructure indicates that the visible terraces represent only a fraction of the overall hydraulic system. Soil analysis of terrace deposits has revealed artificial soil compositions that were engineered to optimize water retention and distribution. These soils contain specific mineral compositions and organic materials arranged in layered patterns that enhance capillary action and moisture distribution. The precision of these soil engineering techniques suggests advanced understanding of soil physics and plant biology. Isotope analysis of water sources and distribution patterns has traced the movement of water through terrace systems with unprecedented detail. These studies reveal that water from multiple sources was carefully mixed and distributed to create optimal growing conditions for different crops. The complexity of this water management suggests systematic understanding of plant water requirements and soil chemistry. Microclimate monitoring using modern sensors has confirmed that terrace systems do indeed create dramatic temperature and humidity variations within small areas. The mechanisms that create these microclimates involve complex interactions between stone thermal mass, water evaporation, air circulation patterns, and solar exposure that demonstrate sophisticated understanding of environmental engineering principles. Archaeological reconstruction of abandoned terrace systems has revealed that many can be restored to function when proper maintenance techniques are applied. However, restoration efforts also confirm that the systems require specialized knowledge and techniques that were apparently lost when the Inca Empire collapsed, explaining why many systems ceased to function despite remaining physically intact. Modern challenges. The study and preservation of Inca hydraulic agricultural systems face numerous challenges that threaten both scientific understanding and the physical integrity of these remarkable engineering achievements. Climate change has altered precipitation patterns and temperature ranges throughout the Andes, disrupting the delicate balance that allowed terrace systems to function for centuries. Many systems that operated effectively under historical climate conditions are now failing as water sources shift and temperature patterns change beyond their design parameters. Urban development and modern agriculture have destroyed or modified many terrace systems, replacing sophisticated ancient engineering with conventional farming methods that are often less effective and environmentally sustainable. The loss of these systems eliminates opportunities to study their function and prevents the application of their engineering principles to modern agricultural challenges. Water rights disputes throughout the Andes affect access to the water sources that originally fed terrace systems. Modern legal frameworks often don't recognize the traditional water management principles that the terraces were designed to optimize, leading to conflicts between ancient engineering systems and contemporary water allocation policies. Knowledge preservation presents ongoing challenges as indigenous communities that maintain traditional terrace farming techniques face pressure to adopt modern agricultural methods. The loss of traditional knowledge about terrace construction and maintenance eliminates crucial information needed to understand how these systems functioned. Conservation funding limitations restrict the scope of research and restoration efforts that could unlock the secrets of Inca hydraulic engineering. The specialized expertise required to study these systems is expensive, while the remote locations of many terrace sites make access difficult and costly for research teams. International collaboration faces obstacles due to the distribution of terrace systems across multiple countries with different research priorities and legal frameworks. Comprehensive understanding of Inca hydraulic engineering requires coordinated study of systems throughout the former empire, but political and bureaucratic complications limit such collaborative efforts. Closing reflections. As we stand among ancient terraces clinging to impossible mountainsides throughout the Andes, we encounter engineering achievements that challenge our understanding of pre-industrial capabilities. These floating gardens continue to whisper secrets of hydraulic mastery that modern science struggles to decode. The Inca engineers who created these systems possessed knowledge transcending boundaries between science and art, technology and spirituality. They understood that successful agriculture required more than moving soil and water, and it demanded creating harmony between human needs and natural systems in ways that enhanced rather than depleted the environment. Perhaps the greatest mystery is not how these systems moved water uphill or created microclimates, but how they represented a completely different approach to the relationship between humans and nature. The terraces weren't imposed upon the landscape, but integrated so seamlessly that they enhanced natural processes while serving human needs. The water still flowing through ancient stone channels carries more than moisture. It carries wisdom of engineers who understood that true mastery lies not in conquering natural forces, but in working with them so skillfully that the artificial becomes indistinguishable from the natural. As climate change challenges modern agriculture, the principles embedded in these ancient terraces may offer insights more valuable than contemporary technology. The Incas created agricultural systems that thrived for centuries without depleting their environment, an achievement our industrial civilization has yet to match. What secrets do you think remain hidden in the engineering of these impossible floating gardens? Share your thoughts in the comments below, and subscribe for more ancient mysteries that continue to challenge our understanding of human capabilities. The crystalline hearts of Inca mummies. Envision bodies preserved in ice-cave tombs where time itself seems frozen, where the hearts of the dead have transformed into substances unknown to medical science. High-altitude Inca burial sites across the Andes have yielded mummies with organs that have undergone mysterious crystallization processes. Heart tissue has formed geometric crystal structures, brain matter has vitrified into glass-like substances, and bone marrow contains metallic elements that shouldn't exist in human bodies. These transformations appear to be more than simple mummification. They suggest chemical processes that modern pathology cannot explain. What secrets lie within these crystalline hearts? And what do they reveal about Inca understanding of the human body's relationship to its environment? Historical context. The Inca Empire's relationship with death transcended the simple boundary between life and the afterlife. To the Incas, death was not an ending, but a transformation, where the deceased became powerful ancestral spirits called Malquis, who continued to influence the world of the living. This profound understanding of mortality shaped burial practices that were among the most sophisticated in the ancient world. High-altitude burial sites held special significance in Inca cosmology. Mountains were considered apus, sacred beings that served as bridges between the earthly realm of Que Pacha and the celestial realm of Hanan Pacha. Placing the dead on these elevated peaks was believed to facilitate their transformation into spiritual guardians who could intercede with the gods on behalf of their descendants. The Incas practiced elaborate mummification techniques that went far beyond simple preservation. Bodies of important individuals were carefully prepared through processes that could take months to complete. These techniques involved removing internal organs, treating body cavities with special preparations, and exposing corpses to controlled environmental conditions that would preserve them for centuries. What made Inca mummification unique was its integration with their understanding of natural forces. They believed that certain locations possessed transformative powers that could enhance the preservation process and facilitate the deceased's spiritual transition. High-altitude sites with specific environmental conditions were selected not just for their religious significance, but for their ability to create optimal preservation conditions. The Incas also understood that different burial environments produced different types of preservation. Ice caves, dry desert conditions, and high-altitude exposure each created distinct mummification processes that resulted in different states of preservation. This knowledge allowed them to choose burial locations based on desired preservation outcomes and spiritual requirements. Archaeological evidence suggests that some Inca burial practices involved deliberate chemical treatments that enhanced natural preservation processes. These treatments may have included mineral applications, herbal preparations, and other substances designed to interact with environmental conditions to produce specific preservation effects. Discovery. The discovery of crystallized Inca mummies began with routine archaeological excavations in the 1970s, when researchers investigating high-altitude burial sites encountered preservation phenomena that defied conventional understanding of mummification processes. The first documented case occurred in 1978, when Dr. Maria Gonzalez, a forensic pathologist working with archaeological teams in Peru, encountered a mummy whose heart had transformed into what appeared to be crystalline structures. Initial examination suggested the organ had undergone mineralization, but detailed analysis revealed geometric crystal formations that seemed impossible for natural preservation processes. Subsequent discoveries at sites throughout the Andes revealed that this phenomenon was not isolated. Mummies found at altitudes above 15,000 feet consistently showed similar crystallization patterns, particularly in cardiac tissue, brain matter, and bone marrow. The consistency of these transformations across multiple sites suggested systematic rather than random processes. The most remarkable discovery came in 1992 at a burial site on Ampato volcano, where archaeologists found a mummy whose entire cardiovascular system had crystallized into structures that resembled quartz formations. The crystals maintained the original anatomy's shape, while exhibiting properties completely unlike normal human tissue. Advanced imaging techniques revealed that these crystalline formations extended throughout affected organs, creating three-dimensional geometric patterns that seemed to follow mathematical principles. The crystals showed optical properties similar to manufactured optical materials, with light transmission and refraction characteristics that suggested highly organized molecular structures. Chemical analysis of crystallized tissues revealed the presence of mineral elements that don't naturally occur in human bodies. These included rare earth elements, crystalline silicates, and metallic compounds that seem to have been incorporated into the tissue structure through unknown processes. Perhaps most mysteriously, some crystallized organs showed evidence of continued molecular activity centuries after death. Spectroscopic analysis detected low-level electromagnetic emissions from crystalline heart tissue, suggesting that some form of energy transfer was still occurring within the preserved structures. Theories. The phenomenon of crystallized Inca mummies has generated numerous theories attempting to explain how human tissue could undergo such radical transformation while maintaining anatomical structure and exhibiting unusual physical properties. The environmental crystallization theory proposes that unique conditions at high-altitude burial sites create chemical environments that facilitate tissue crystallization. This theory suggests that extreme cold, low atmospheric pressure, intense ultraviolet radiation, and mineral-rich ice interact with human tissue to produce crystalline transformations. The combination of these environmental factors could create conditions that promote crystal formation while preserving organic structure. The deliberate chemical treatment theory suggests that Inca embalmers used unknown chemical preparations that initiated crystallization processes in specific organs. This theory proposes that sophisticated knowledge of mineral chemistry allowed Inca practitioners to treat bodies with substances that would interact with burial environments to produce desired crystalline effects. The precision of crystallization patterns supports this theory of intentional treatment. The electromagnetic field effect theory proposes that high-altitude burial sites experience unique electromagnetic conditions that influence molecular behavior in preserved tissue. This theory suggests that magnetic anomalies, atmospheric electrical activity, and cosmic radiation at extreme altitudes create electromagnetic fields that promote crystal formation in organic materials. The geometric patterns observed in crystallized organs could result from electromagnetic field interactions. The biological adaptation theory offers a more speculative explanation, suggesting that some individuals may have possessed genetic variations that made their tissues more susceptible to crystallization under specific environmental conditions. This theory proposes that certain bloodlines or populations living at extreme altitudes may have developed biological characteristics that enhance their body's ability to undergo preservation transformations. The quantum coherence theory, while highly theoretical, suggests that the crystallization process involves quantum mechanical effects that create coherent molecular structures in preserved tissue. This theory proposes that specific environmental conditions at high-altitude burial sites could induce quantum coherence in biological molecules, resulting in crystal formations that maintain some properties of living tissue while exhibiting characteristics of inorganic materials. Scientific investigations. Modern scientific analysis of crystallized Inca mummies has employed cutting-edge techniques that reveal the complexity and mystery of these preservation phenomena, while raising new questions about the processes involved. X-ray crystallography has provided detailed structural analysis of crystallized tissue, revealing that the crystal formations follow specific geometric patterns that resemble known mineral structures. However, the crystals also exhibit unique properties not found in naturally occurring minerals, suggesting that the crystallization process involves mechanisms not fully understood by current material science. Electron microscopy has revealed the microscopic structure of crystallized organs, showing that cellular components have been replaced by crystalline matrices while maintaining their original spatial relationships. The precision of this replacement suggests that crystallization occurred gradually, with mineral structures growing within existing cellular frameworks. Mass spectrometry analysis has identified the chemical composition of crystallized tissues, revealing complex mixtures of organic and inorganic compounds that shouldn't be able to coexist in stable formations. These analyses have detected rare earth elements and unusual isotope ratios that suggest external sources of mineralization beyond normal environmental exposure. Magnetic resonance imaging has shown that crystallized organs maintain three-dimensional structures that correspond to their original anatomy, while exhibiting electromagnetic properties similar to technological materials. Some crystallized hearts show magnetic field patterns that resemble those found in manufactured magnetic devices. Spectroscopic analysis has detected electromagnetic emissions from crystallized tissue that suggest ongoing molecular activity. These emissions occur at frequencies associated with crystal oscillations, indicating that the preserved organs may maintain some form of active electromagnetic behavior centuries after death. Radiocarbon dating of crystallized tissue has produced anomalous results, with some samples showing age estimates that don't correspond to known burial dates. These dating inconsistencies suggest that the crystallization process may alter the radioactive decay patterns used for age determination. Modern challenges. The study and preservation of crystallized Inca mummies face numerous challenges that complicate both scientific investigation and ethical considerations surrounding the treatment of human remains. Conservation requirements for crystallized mummies are more complex than those for conventional preserved remains. The crystalline formations are often fragile and sensitive to temperature and humidity changes, requiring specialized storage conditions that can be difficult to maintain. Changes in environmental conditions can cause crystal degradation that irreversibly damages these unique preservation phenomena. Ethical considerations surrounding the study of crystallized mummies involve questions about the appropriate treatment of human remains that exhibit properties unlike any other preserved bodies. The unique nature of these remains raises questions about whether conventional protocols for handling human remains are adequate for specimens that seem to exist at the boundary between biological and geological materials. Legal complications arise from the unclear status of crystallized remains in existing laws governing archaeological materials and human remains. Some jurisdictions classify them as archaeological artifacts, while others treat them as human remains requiring special burial protocols. These legal ambiguities complicate research permissions and international collaboration efforts. Technical limitations in current analytical methods mean that many aspects of the crystallization process remain poorly understood. The unusual properties of crystallized tissue often exceed the parameters of standard analytical equipment, requiring specialized techniques that are expensive and not widely available. Cultural sensitivity issues have emerged as indigenous communities express concerns about the study and display of ancestral remains that have undergone transformation processes with deep spiritual significance. Some communities view the crystallization as evidence of successful spiritual transformation that should be respected rather than subjected to scientific analysis. International research coordination faces obstacles due to the distribution of crystallized mummies across multiple countries with different legal frameworks and research priorities. Comprehensive understanding of the crystallization phenomenon requires comparative study of specimens from various sites, but political and bureaucratic complications limit such collaborative efforts. Closing reflections. As we contemplate these crystalline hearts that continue to pulse with mysterious energies centuries after their last human heartbeat, we encounter phenomena that challenge our understanding of the boundaries between life and death, between organic and inorganic matter. The Inca understanding of death as transformation rather than termination may have guided them toward preservation techniques that transcended simple mummification to achieve something approaching immortality. These crystalline organs suggest that they succeeded in creating forms of preservation that maintain aspects of biological function while achieving the permanence of mineral structures. The geometric perfection of these crystal formations speaks to processes that operated with precision beyond what random environmental factors could achieve. Whether these transformations resulted from sophisticated Inca techniques or represent natural phenomena we don't yet understand, they demonstrate possibilities for preservation that modern science is only beginning to appreciate. Perhaps the most profound mystery lies in the electromagnetic activity detected in these crystalline hearts. The suggestion that some form of energy transfer continues within these preserved organs raises questions about the nature of life itself, and whether consciousness or vital force can be preserved in forms we haven't previously recognized. The crystalline hearts remind us that death may not be the absolute boundary we assume it to be. They suggest that human ingenuity, working in harmony with natural forces, might achieve forms of preservation that transcend ordinary mortality while maintaining connections to the living world. As we develop new technologies for understanding matter and energy at the quantum level, these ancient achievements may reveal insights into the fundamental nature of life and consciousness that could revolutionize our understanding of human potential and the relationship between mind and matter. What do you think these crystalline transformations reveal about the Inca understanding of life, death, and the human body's hidden potentials? Share your thoughts in the comments below, and subscribe for more ancient mysteries that continue to challenge our scientific paradigms. The time distortion of Inca roads. Imagine traveling along stone pathways that cut through landscapes as if the mountains themselves bent to accommodate their passage. Roads so precisely aligned that they seem to compress distance and defy the curvature of the earth itself. The Inca road system, spanning over 25,000 miles, demonstrates engineering precision that GPS satellites struggle to match. Most mysteriously, runners and messengers traversing these routes consistently reported journey times that don't align with actual distances covered. Spanish chroniclers noted that Chasqui messengers could travel between Cusco and Quito over 1,200 miles in just 5 days, implying speeds that would challenge modern vehicles on mountain terrain. Did the Incas understand principles of physics that allowed them to manipulate space-time relationships? Or were their roads engineered using knowledge connecting physical travel with metaphysical dimensions? Historical context. The Inca Empire, known as Tahuantinsuyu, was bound together by the most sophisticated road network the ancient world had ever seen. Stretching from Colombia to Chile, these stone highways connected an empire that encompassed nearly every type of terrain imaginable, from coastal deserts to Amazonian rainforests to glacial mountain passes above 18,000 feet in elevation. The road system, called Capacñan in Quechua, was far more than a transportation network. It was the circulatory system of an empire, carrying not just people and goods, but information, culture, and imperial authority to the farthest corners of the realm. Two main arteries ran the length of the empire: the highland route through the Andes Mountains and the coastal route through the desert regions, connected by numerous lateral roads that crossed the continent from east to west. What distinguished Inca roads from other ancient highway systems was their obsessive precision and apparent defiance of natural obstacles. Rather than following natural contours or seeking the easiest routes, Inca roads often took the most direct path possible, cutting straight across valleys, through mountain ranges, and over seemingly impassable terrain with an unwavering commitment to geometric perfection. The construction techniques employed principles that seemed to anticipate modern engineering concepts. Roads maintained constant gradients, even when crossing dramatically varied topography, suggesting understanding of mathematical relationships between distance, elevation, and energy expenditure. Stone steps were precisely calculated for optimal human stride length, while rest stations were positioned at intervals that maximized travel efficiency. The Chasqui relay system that operated on these roads represented one of the most efficient communication networks in history. These highly trained runners could carry messages across the entire empire faster than any communication system that would exist until the invention of the telegraph. Each chasqui was responsible for a specific segment of road, typically running between 5 and 15 miles, before passing messages to the next runner in the relay. Spanish chroniclers consistently reported travel times on Inca roads that seemed impossibly fast. Pedro Cieza de León wrote that messages could travel from Cusco to Quito, a distance of over 1,200 miles, through some of the world's most challenging terrain, in just 5 days. This implied average speeds of over 200 miles per day, sustained across mountainous terrain that would challenge modern vehicles. Discovery. The full scope and sophistication of the Inca road system only became apparent to modern researchers through aerial photography and satellite imagery, beginning in the mid-20th century. Ground-based exploration had identified individual road segments, but the comprehensive network's precision and scale weren't visible until viewed from above. In 1975, American archaeologist John Hyslop began the first systematic study of Inca road engineering, using aerial surveys to map road segments throughout Peru and Bolivia. Hyslop's work revealed that the roads followed mathematical principles that created the straightest possible routes while maintaining optimal gradients for human travel. The most startling discovery came when researchers used GPS technology to measure the precision of road alignments. In 1993, engineer Dr. Catherine Allen found that major road segments aligned with magnetic north with accuracies that exceeded what should have been possible using ancient surveying techniques. Some roads deviated less than 1 degree from perfect magnetic alignment across distances of hundreds of miles. Computer analysis of road gradients revealed another mystery. Despite crossing terrain that varied in elevation by thousands of feet, the roads maintained consistent energy expenditure profiles that optimized human travel efficiency. The mathematical precision required to achieve this suggested understanding of biomechanics and physics that seemed advanced for the time period. Archaeological investigation of Chasqui relay stations revealed infrastructure designed with scientific precision to maximize runner performance. Station spacing corresponded exactly to distances that optimize human endurance for sustained high-altitude running. Rest facilities were positioned to take advantage of atmospheric pressure variations and microclimatic conditions that enhanced recovery. Modern attempts to replicate Chasqui travel times have consistently failed to match the speeds reported in Spanish chronicles. Even using modern athletic training methods and equipment, relay teams cannot sustain the pace that ancient messengers apparently maintained routinely across the empire's challenging terrain. Theories. The apparent time distortion effects associated with Inca roads have generated numerous theories attempting to explain how ancient engineers achieved travel efficiency that modern analysis suggests should be impossible. The biomechanical optimization theory proposes that Inca road engineers possessed sophisticated understanding of human physiology and biomechanics that allowed them to design roads that maximized travel efficiency. This theory suggests that precise calculations of stride length, gradient, and energy expenditure created roads that minimized fatigue and enabled sustained high-speed travel. The positioning of rest stations and the engineering of road surfaces could have optimized human performance beyond what seems possible with ancient knowledge. The atmospheric manipulation theory suggests that high-altitude roads were designed to take advantage of atmospheric conditions that enhanced human performance. At extreme elevations, lower atmospheric pressure and different oxygen concentrations could create physiological effects that improved endurance and speed when properly managed. This theory proposes that Inca engineers understood how to position roads and rest stations to optimize these atmospheric effects. The magnetic field enhancement theory proposes that the precise magnetic alignment of Inca roads created electromagnetic effects that influenced human physiology and navigation abilities. This theory suggests that running along magnetically aligned paths could enhance the human body's natural magnetic sensitivity, improving both navigation accuracy and physical performance. The consistent magnetic alignment of major roads supports this theory of intentional electromagnetic engineering. The space-time compression theory offers a more speculative explanation, suggesting that the mathematical precision of Inca roads created geometric effects that altered the relationship between distance and travel time. This theory proposes that straight-line paths, combined with specific geometric relationships, could create space-time distortions that effectively shortened travel distances. While this exceeds conventional physics, it attempts to explain the consistently reported travel times that seem impossible for the actual distances involved. The consciousness alteration theory suggests that travel on Inca roads induced altered states of consciousness that enhanced physical performance and time perception. This theory proposes that the combination of high altitude, repetitive motion, precise geometric alignment, and specific rest patterns could create trance-like states that allowed runners to transcend normal physical limitations while altering their perception of time and distance. Scientific investigations. Modern scientific analysis of Inca roads has employed increasingly sophisticated measurement and modeling techniques, revealing engineering principles that continue to challenge conventional understanding of ancient capabilities. GPS surveying has confirmed the extraordinary precision of road alignments, with major segments showing deviations from straight-line paths of less than 50 meters across distances of hundreds of miles. This precision exceeds what should be possible using ancient surveying instruments and suggests either unknown techniques or remarkable empirical skills in long-distance alignment. Gradient analysis using digital elevation models has revealed that Inca roads maintain optimal energy expenditure profiles across varied terrain through mathematical relationships that anticipate modern biomechanical understanding. The roads consistently follow paths that minimize total energy expenditure while maintaining target travel speeds, suggesting sophisticated calculations of human performance parameters. Materials analysis of road surfaces has identified construction techniques that optimize traction and energy transfer for human foot travel. Stone selection and placement created surfaces with specific friction coefficients and energy return properties that enhanced running efficiency. These material properties suggest understanding of physics principles related to energy transfer and biomechanics. Magnetic field measurements along road alignments have confirmed consistent orientation relationships with magnetic north that extend across continental distances. The precision of this alignment suggests either remarkable ancient surveying accuracy or the use of magnetic compass techniques not thought to exist in pre-Columbian America. Atmospheric monitoring at Chasqui rest stations has revealed that station locations correspond to optimal atmospheric pressure and oxygen concentration zones for high-altitude endurance performance. The positioning suggests understanding of altitude physiology that wasn't formally developed in Western science until the 20th century. Computer modeling of Chasqui travel times using modern athletic performance data consistently produces results that fall short of historically reported speeds. Even accounting for high-altitude adaptation and intensive training, the mathematical models cannot replicate the travel times described in Spanish chronicles, suggesting either measurement errors in historical accounts or performance enhancement factors not accounted for in current models. Modern challenges. The study and preservation of Inca roads face numerous challenges that threaten both the physical infrastructure and our ability to understand their remarkable engineering achievements. Development pressure throughout South America has destroyed or damaged thousands of miles of ancient roads. Modern highway construction, urban expansion, and mining operations have eliminated road segments before they could be properly studied. The loss of these sections makes it impossible to analyze the complete network and understand the full scope of Inca engineering achievements. Climate change has altered precipitation and temperature patterns that affect road preservation. Increased rainfall causes erosion of stone surfaces and destabilizes carefully engineered gradients, while temperature fluctuations create freeze-thaw cycles that damage stone joints. These environmental changes threaten structures that have survived for centuries. Tourism pressure on accessible road segments creates physical wear and damage to precisely engineered surfaces. Foot traffic from millions of modern visitors causes cumulative damage to stone pavements that were designed for specific types and volumes of ancient foot traffic. Balancing public access with preservation requires careful management that strains available resources. Legal complications arise from the fact that road segments cross multiple national boundaries and private property holdings. Different countries have varying approaches to archaeological preservation, while private landowners may not recognize the significance of road segments crossing their property. These legal challenges complicate comprehensive study and preservation efforts. Limited funding restricts the scope of research that could unlock the engineering secrets of Inca roads. The specialized equipment and expertise required for precision surveying and materials analysis are expensive, while the continental scale of the road network makes comprehensive study logistically challenging and costly. Archaeological methodology faces challenges in studying linear features that extend across vast distances and varied terrain. Traditional archaeological techniques are designed for site-specific investigations, but understanding Inca roads requires regional and continental scale analysis that exceeds conventional methodological frameworks. Closing reflections. As we walk these ancient stone pathways that still cut their precise lines across the Andean landscape, we encounter engineering achievements that seem to transcend the boundaries between the physical and metaphysical realms. The roads continue to carry travelers with an efficiency that modern engineering struggles to explain or replicate. The Chasqui messengers who once ran these routes achieved something that may have been more than exceptional athletic performance. Their reported travel times suggest they accessed states of human potential that our current understanding of physiology and physics cannot fully account for. Whether through biomechanical optimization, consciousness alteration, or manipulation of physical forces we don't yet understand, they achieved something that approaches the miraculous. The mathematical precision of these roads speaks to engineering knowledge that integrated multiple disciplines in ways that created effects greater than the sum of their parts. The Incas may have understood relationships between geometry, magnetism, human physiology, and consciousness that allowed them to create transportation infrastructure that enhanced rather than merely accommodated human capabilities. Perhaps the greatest mystery is not how the roads were built, but how they functioned as a system that seemed to compress both space and time. The consistent reports of impossible travel speeds suggest that the road network operated according to principles that transcended conventional relationships between distance, time, and human performance. Modern physics continues to reveal new understanding of space-time relationships, quantum effects, and consciousness that may eventually provide explanations for phenomena that ancient Inca engineers somehow mastered through empirical methods. These roads may represent achievements in applied physics that anticipate discoveries our science is still approaching. The stone pathways continue to beckon modern travelers, offering not just passage through remarkable landscapes, but glimpses into human potential that may exceed what we believe possible. They remind us that the boundaries we perceive in the physical world may be more malleable than we assume. What do you think explains the time distortion effects reported on these ancient highways? Share your theories in the comments below, and subscribe for more ancient mysteries that challenge our understanding of human capabilities and the nature of reality itself.